In this video, we are going to start our first practical implementation. Already, we have covered up the theoretical part of linear regression. We have understood the maths in-depth intuition. We have understood about gradient descent. We have understood about the performance metrics that we are going to use, like R square and adjusted R square. Now let's go ahead and implement a project with the help of linear regression. And we'll try to see that, okay, whenever we have given a data set, and this is a very simple project, guys, just to begin with, so that it'll actually help you to build up some amount of confidence, okay? So first of all, what we are going to do in this is that we are taking an amazing data set, which is called as Boston housing data set. And the main aim of that particular data set is that we really need to predict the price of the house based on various features. Now we are going to see what all features are there and what all things are not there, which are the important features and all. We'll do a lot of EDA, we'll try to come up with some conclusions, and then we'll try to implement a linear regression machine learning implementation altogether, right? So to begin with, let me quickly make some cells so you can use shortcut like escape A. So this is a Jupyter notebook over here. So let's begin. First of all, what we are going to do is that we are going to import some libraries, like import pandas, because pandas are super important in this. Import, and I'm going to write each and every line of code and parallelly try to explain you. Import numpy np, and some more libraries I want is that import matplotlib.pyplot as plt. So this is the library, and for inline display of the graphs or any visualization that we do, I'm also going to import matplotlib inline, right? So all these things are definitely there. So I have imported all these things. Now to begin with, what we are going to do is that let's load the data set. Okay, let's load the Boston house pricing data set. Now this data set right now, if I really want to think about it, it is already present in a library, but we'll try to see as we go ahead, we'll take up different problem statement, and we are going to make sure that we'll understand about, from different files or different sources, we'll try to take out the data set and apply machine learning algorithm. So today in this video, we are going to use from sklearn, because sklearn also has a lot of data sets altogether within themselves. So I'm going to import the data set, and I'm going to say import load Boston. Okay, so there is something called as load Boston. Along with that, there are different data sets which you can definitely explore. Then this will be my Boston underscore df. So here, let's go ahead and write Boston underscore df. I'm just going to call this load Boston and quickly print it. First of all, let's see what is the type that we are getting with respect to this Boston underscore df. It is nothing but sklearn.utils.bunch. So this bunch is nothing but, if I probably write just dot keys, you'll be able to see that I'll be getting various keys, right? Like data. Here you can see target, feature names, description, and file name. Okay, everything will make sense, once I go ahead and see all these features. Okay, now first of all, I really want to see what is this DESCR. This basically says that this is the description of the entire data set. So let's check the, and always it is a good way that you should probably write each and every comments whenever you're doing any kind of coding. So let's check the description of the data set to begin with. Okay, so here you will be able to see the description of the data set. All you have to do is that just write print whatever is your information, like this Boston underscore df. Here I'll not say df also, let me just name it as Boston, because df we basically say it for data frames, and right now I'm taking out the entire data set, so no need to write df. So print Boston dot descr. So once I print this, here you'll be able to see the entire information about this particular data set. So this is a Boston housing price data set. Number of instances, that basically means how many number of data points are there. There are 506. Number of attributes, there are 13 numerical or categorical predictive. Median value attribute is usually used as the target. Here you will be able to see various features that are present in that specific data set, like CRIN. This basically means per capita crime rate by town. So in that, the house in which town it basically exists, how much per capita crime rate is. And obviously, if this increases, the price will definitely decrease. Then you have other features like ZN, proportion of residential land zone for lots over 25,000 square feet. Then you have Indus, proportion of non-retail business acres over town. Cache, char, river, dummy variable. Knox. So if track bounds river, zero otherwise. Knox basically saying nitric oxide concentration. Again, if this is more, obviously it will basically in that specific town you'll have more amount of pollution, right? Then you have RM, average number of rooms per dwelling, age, dis, rad, tax, PT ratio, B, LStat. So you can find out all this information. PT ratio basically means pupil teacher ratio by town. LStat basically means lower status of the population, median value of owner occupied homes in thousands dollars basically. Okay, so that is giving you the information of MEDV. Okay, so just check out all this information. And if I go forward, right, how do I see what are the data with respect to this specific feature, and what is the output feature? Output feature is obviously the price of the house. What are the feature names? So what I will do is that quickly just go ahead and write print Boston underscore data. So this will be the data that is given with respect to all this information, right? So here you'll be able to see what are my input features. These are all my input features. And for this input feature, I specifically have my input data that is given in this way, right? And if you probably try to see this, this will be a nested sublist. So this basically indicates that all the feature values for the first record will be present over here. For the second record will be present over here. Now this is what data basically says. If I really want to find out what is the price, so here you can basically print Boston dot target. So this will basically be the price of the house based on all the data points that I have, and this will be a single list. That is simple. Similarly, if you really want to go ahead and see what is the features, right? So here you can basically add Boston dot feature names. So here are all my features that are available over here, right? So these are some of the information regarding the dataset. It is always important to understand the dataset, and I hope everybody has got an idea like what all information you are able to retrieve from this. And again, you can also find out this is basically also present in this particular repository. This is the URL over there. The data set was taken from so and so library. So here you can basically see all the information regarding the data set itself, right? So now let's go ahead and let's try to do some EDA in probably in the next video. But here I think introduction with respect to the data set and understanding of the data set is very much clear for you. Okay, so yes, let's go ahead. And you can also convert this entire data set into a data frame, which we will do in our next video. So yes, I'll see you all in the next video. Thank you. So guys, now in this video, we are going to prepare the entire data set. In our previous video, we understood about the entire data set with respect to the Boston house pricing data set. So with respect to the preparation, first of all, what we are going to do is that let's go ahead and create my data set altogether. And this data set here, I'm actually going to take and I'll be using pd.dataframe. This will actually help us to create the entire data frame altogether with respect to all my independent features. So here you can see all my independent features are there, right, in boston.data. So if I probably write pd.dataframe on boston.data, here you'll be able to see that I will be getting a data set which look like this, right? So yes, obviously if I write dataset.head, it will give me the top 5 records. So these are my first record, second record, and third record, fourth, fifth, like this. All the records are available. Now, one thing that I feel over here is that because over here, I still don't have my column names, right? Now, if I really want to put up all the column names, then how should I do it, right? So there are two ways. One is that when we are creating the pd.data frame, here obviously you have something called as a column features. Now in this column features, what you can actually do is that you can just write Boston dot features name, right? So if you write Boston dot features name, here you will be able to see the entire data set with the column name. So here obviously I can see all my column names and the entire data set, but still we are missing the output feature. These are all my independent features, right? At any point of time, whenever I probably see, right, in my data set there will be one output or dependent feature and remaining all will be my independent features. So how do I put up my output feature in this specific data set? My output feature is basically present in boston.target. So what I'm actually going to do, I will take up this data set and I will create a new field which is called as price. And this price will basically have my output feature, and this I'm going to assign it to boston.target, right? So if I assign this to boston.target, you will be able to see that my data set will now have, if I write probably dataset.head, head will basically give me the top 5 records. So here is my output feature with respect to price also, right? So here you can see that we have prepared the data set. Now this is my complete data set over here. Now with respect to this data set, what we have to do is that quickly do some kind of quick analysis, and that analysis is super important. Now first of all, what I'm actually going to do is that I'm going to use some of the inbuilt function like dataset.info. So if I write dataset.info, it is basically going to talk about like what are the data types of my all the columns that are present over here. And here you can see that all it is floating 64 bits, right? And it is obviously non-null. And yes, one more important point is that we also need to check whether there is any kind of missing values or not, right? So here, these are some basic information about your data set. It talks about like your specific columns, what data type it is. Let's say if it is a categorical kind of data type, then we have to do a different kind of pre-processing. But here, since this is just our first problem statement, I've just taken a simple one and we'll try to implement this. Okay, so here is my dataset.info. With respect to this, I have all the information that is present over here. This is fine. Now, since this is already in the floating point, I hope you know about percentiles, like 25 percentile, what is the medium, 75 percentile. So if I really want to describe my entire data set, so I can also use something called as, or I can also say summarizing the stats, right? Summarizing the stats of the data. Okay, so in order to do this, I will just use dataset dot describe. So describe is one function, and this will probably give you the count, mean, standard deviation, mean 25%, 50%, 75%, and max. Remember, one thing is that suppose if you have features that are like categorical features, so in this describe, you'll not get that category features. All the input features or all the independent or the output features that are numerical, right, that will be considered while finding out your entire 25 percentile, 50 percentile, 75 percentile, and all the other information. So in short, here we are summarizing the entire statistics. Okay, now till here we have done this. We have prepared our data set. We have seen some of the information with respect to how to summarize your data, how to see the generic information. Whenever you get a data set, you have to first of all check the missing values. Okay, so this is a super important step. Check the missing values. Okay, I'll again say that this step is super important whenever, because the first thing is that whenever I have my data set, I really need to check the missing values. So in order to do this, I'll be using dataset dot is null function. If I basically use dot is null, it is just going to tell me that which rows are true or false. If there is any value that is true, let's say with respect to this particular feature, if this is true, that basically indicates that on the record of 501, this particular value is missing, right? So obviously most of the values are some, but still I'm not able to see all the records over here because some of the records are missing. So what I can do, I can also apply an aggregate function called as dot sum. So it basically says that, okay, fine, there are no missing values as such. So since this was a simple problem statement, as I took my first problem statement, so I had actually done this. Later on, when we'll be seeing different problem statements, we will try to see whether there is any kind of missing values or not, and we'll also see how we can replace this particular missing values. So obviously, no missing values over here. We are good to go. Okay. Now, what we are going to do is that after we have done this, we are also now going to do some EDA, right? Exploratory data analysis. Okay, so in this exploratory data analysis, we are just going to analyze some information of a data. Now, you know that over here, I don't have any missing values. I've seen, okay, this is floating point numbers, right? And obviously, when I see this floating point numbers, the best thing is that in a case of a regression problem statement, the first thing that you should definitely run, or first code that you should definitely run, is related to correlation. Correlation is super important in um, in any regression problem statement, because we really need to find out how the independent features and my output features are correlated. If they are highly positively correlated or highly negative correlated, then this basically indicates that our model performance will definitely be high. Okay, so this is one of the super important property with respect to linear regression. Here, first of all, I'm just going to implement some of the things, implement completely, and then probably I'm going to make again a theoretical video to make you understand about the assumptions of linear regression. Super important. Now, in order to do this, obviously, what is the technique that I'm actually going to use? Here, I'll just write pandas pd. So let's see pd dot. So I'm just going to use pd dot. Okay, no need to use PD. So if I can write df dot correlation. So here, if I write df dot corr, so sorry, not df, it should be dataset, because that is what is the generic thinking, right? We always try to write df over there. So here you will be able to see the correlation. Now, if I probably see the definition with respect to this, the by default correlation that you'll be able to see is something called as Pearson. Okay. Now, Pearson correlation basically checks the relationship between two features X and Y in such a way that it will try to say that whether it is highly positively correlated or negatively correlated, or it is not at all correlated. Usually the output of the Pearson correlation ranges between -1 to +1. The more towards the value towards +1, more positively correlated it is. More the value towards -1, the more negative correlated it is. And if it is near to 0, hardly they are correlated. Okay. So this is super easy way to basically check how the correlation basically exists. Now here, the two types of correlation that you really need to check: the correlation between independent feature and the correlation between independent and the dependent feature. If there is a high correlation between independent features, at that point of time, you can remove one of the independent features, because that is what is called as multicollinearity. So in linear regression, also we really need to check what is multicollinearity. In that, it basically means that if my two independent features are very highly correlated, let's say they're correlated by 95%, 96%, or negative 90, negative minus 0.95, 0.96, because here we will be getting the value between -1 to +1. So if that is highly positively correlated or highly negatively correlated, what we can do with respect to the independent features, we can drop one of the independent feature and we can just take the other one. The other correlation that we really need to focus on is the correlation between our independent features and our output feature, that is price. Now here you can see, if I probably take this example, CRIM and price, these are like negatively correlated by 0.38, like -0.38, so somewhere around 38%. Similarly, if I see ZN with respect to price, it is nothing but 0.36, right? Now what is, let's say, what is the CRIM? Obviously, and this will probably give you the entire information. CRIM basically says that it is the per capita crime rate by town. So obviously, if this increases, right, this increases, your house price will definitely decrease, right? So that is the reason why price is decreasing by -0.38. If the crime increases in a specific town, it will decrease. Similarly, all the other features are there. So here, obviously, from some of the features here, you can see RM is somewhere around 69% correlated, positively correlated, and this age is somewhere around -0.37 negatively correlated. So what we will do in the next video is that we will try to analyze this correlation. We'll try to analyze this correlation by constructing some of the important plots. Okay, some of the plots like scattered plots or heat map, or we'll also see some of the outliers, whether there is some outliers in the price or not. But this correlation is super important. Two things that you really need to check: one is for multicollinearity, and to check for multicollinearity, there are also some other methods which we will discuss as we go ahead. But definitely, multicollinearity is the relationship between the independent features that you have to check. And obviously here, if I see, right, there is no much independent features that are very highly positively correlated or negatively correlated, right? So here, if you could see, like in this particular example, you can say tax and index, it is somewhere around 72% correlated, but I'll not still say that it is very highly correlated, right? So I will definitely not drop any of this feature. Otherwise, let's say if this feature was like 96% correlated, I could have dropped index and probably considered tax or index, any one of them. and probably used for training my model, right? So this is a super important part with respect to the correlation. Now, with respect to this information, what I will be doing is that one more thing is that based on this correlation, right, we can also do a scatter plot. So for this, I'll be using Seaborn, right? And import Seaborn as SNS, and I will be using something called as sns.pairplot. Now this pair plot will basically give me the how x and y coordinates, like basically how this feature CRIM and price is basically scattered with respect to different points, right? So if I probably write df, and let's see whether there are any other features that are present over here. Or let me just explain this. Sorry, this should be dataset. My mistake. So here you'll be able to see that okay, it'll take some time because there's so many features, and obviously with respect to different features there will be a different plot, scattered plot in short, that you'll be seeing. Okay, so this is getting executed again, some 5 to 6 seconds max, I guess, and here you'll be able to see the entire plot. Okay, now obviously this plot that you'll be seeing, let me just open or zoom in. Obviously, you will not be able to see much information over here, but you can see some of the data that is plotted between two features, right? They have some type of positively or negatively correlation, right? So this information is hardly visible, so I would again focus on this correlation itself, because this same value, how is this distribution, right? Based on that, this is entirely calculated, right? So this is also one more way how you can see visually. If you have less number of features, you can see it much more clearly. Otherwise, I think this is the information. Let's consider that this specific feature as there, like this is CRIM, okay, and my last feature is something price. So if you see the relationship between this two, it is somewhat negatively correlated, right? Somewhat negatively correlated. So here you can see CRIM and price is negatively correlated because my data points is in the inverted manner, right? So definitely check out this information. Now in my next video, what I'm actually going to do, I'm going to do a lot of analysis based on this information that is present. Okay, so thank you. I'll see you all in the next video. In this video, guys, we are going to continue the discussion with respect to this Boston housing price data set. And now we are going to analyze the correlated features. Now, already you have seen that this is how our features will look like. We have to really analyze with respect to the independent and the dependent feature. So here, let's say that the CRIM, which is the feature that is related to crime rate. And if I probably see the relationship with respect to price, if I want to quickly create a scattered plot, all I will do is that something I write plt.scatter, and here I can basically use df dot my feature name, that is CRIM, along with the price, right? So I'll write df dot of price, and again this is not df, in short this is data set. Okay, so I will quickly see to it, and let's see how the graph will look like. And here you can basically see the graph. Okay, this feature is wrong, data set. Okay, now here you can definitely see that the relationship between crime and price is that as the crime keeps on increasing, because in the x-axis here you can see that it is having crime. So here you can also put some x label and y label. So here you'll be able to see this will be my crime rate. I'm just writing something like crime rate, and plot dot y label, you'll be also able to see the crime rate, plus on the y label you'll be able to see the price. So now here you can definitely see the relationship between the crime rate and the price. Obviously, when the crime rate is increasing, right, the price will also keep on decreasing. Sorry, this is inversely correlated. Here you can see it is like minus 0.388. In that specific percentage is reversely or inversely correlated. So that is the reason why you are able to find this kind of scattered plot. Okay. Now, similarly, what you can do is that with respect to some of the features, let's consider one of the feature over here as RM. And here I can see, okay, it is 69% positively correlated. So if I really also want to plot this, I can plot it over here, and always make sure that you write all the information and observation that you're able to make it. Okay. So here in my X label, it will be RM, and this will be price, right? RM, I think it is nothing but room, RM, what is the RM feature over here? Let's consider the RM feature, average number of rooms per dwelling. So obviously, as the number of rooms keeps on increasing, your price will also keep on increasing, right? Now, let's say that if this is my feature, if I just have one independent feature and one price, and if I try to probably create a regression plot, how it will look like. So for this, I'll be using Cborn, right? Cborn as SNS, and here I can write sns.reg plot, which is also called as regression plot. And here, let's take what all features are required: X feature, Y feature. Now, in this particular case, let me say that my X feature is nothing but RM. Okay, my Y feature is nothing but price. And after this, I also have to give my data. So here you can basically see my data is none over here, but I'm going to basically write data is equal to dataset, which is my entire feature. And if I probably execute it, so you can here you can see that the same plot is basically displayed over here. And here you can see that we are able to create a simple linear regression line, and about some amount of variation will always be there. That is also given over here, right? So here clearly you can see that, okay, there is a positive correlation that is actually between RM and price. Now similarly, you can also take up any other feature that are present. So one interesting feature that I can see is LSTAT and price. This is somewhere on negative correlation, right? So again, to analyze it, it will always be better that I will just copy this part and paste it over here. Here, I'm just going to use LSTAT, and this will be my price. So if I execute this, here you can see obviously this is negatively correlated, and you can basically create a regression plot like this, right? So this is some amount of analysis that you can do. Again, you can check out with respect to other features also. Let's consider some of the features that are not at all correlated. Let's say cash, CHAS and price, right? So if I probably see this and if I try to print it, so here you will be able to see that CHAS and price. Now here, with respect to this, the data points look somewhere here. It is something like this. It is something like this. And there we are trying to create a best fit line. Now, it is super important that to understand that linearity should definitely be there in your data set. If linearity is not there in a data set, linearity basically means when X is increasing, Y is increasing, or if X is decreasing, Y is decreasing, this kind of relationship should be there, or inverse relationship should be there to create a better regression model. So usually whenever we have this kind of features that are hardly correlated, right, it reduces the error of the regression model. Okay. Now, quickly, let's go ahead and do some more things. And obviously, guys, here you have to write down the observations. Okay. Here also you have to say that as the LSTAT is decreasing, the price is increasing. Okay. Or here also you can basically say as the RMs, that is number of rooms are increasing, price is increasing. Let's take up one more, and there is something called as PT ratio. PT ratio. Okay. So what about the PT ratio? PT ratio was something like parent to tutoring something. Okay, pupil teacher ratio by town. Okay, so this was the feature over there. So let's go ahead and try to do with PT ratio. Again, I'm going to copy the same thing over here, and this was something like PT ratio. Okay, so here you will be able to see that, okay, some amount of negative correlation is there, but again, there are some types of points that are available. And this information, it is also saying that as PT ratio increases, price decreases, or as when the PT ratio increases, as the PT ratio decreases, the price increases. So there is an inverse relationship. Okay. Now, these are some of the information that I could take out from this particular data set. Now, let's go ahead and quickly do one important thing, that is create our models. And for creating our models, we'll do, first of all, there are multiple steps that we really need to perform. That is like we need to prepare our independent and dependent features. We need to make sure that we need to perform, after we create our independent and dependent features, we need to do train, test, split, and many more things. Okay. So let's do all these things and let's see that how we are able to do it. Okay. So the first step is basically dividing our features into independent and dependent features. Okay. So as you know, this is my entire data set. and inside this data set, I know price is my dependent feature and remaining all are my independent features, right? So let's quickly go ahead and let's try to create this particular data set. So here I will just name all my independent features as X. So here I'm just going to use df.ilock, and I have to make sure that I take all my input features and I have to skip the price column. Okay, so here it is. So colon comma colon minus 1. If I do colon comma colon minus 1, that basically means I'm going to skip up all the independent features. Sorry, I'm going to take up all the independent features and just skip the last column, right? That is price. So this will basically give me my independent features. Similarly, with respect to Y, I'm just going to use df.ilock. Here I'm going to take all my features, and then not all my features, all my data points, and then I'm going to probably take the last column, that is price. Okay, so if I execute this, okay, this data df, again it should be data set. I'm extremely sorry about it. Okay, so this should be my data set, and here I actually executed. It's okay, guys. See, if I'm making some mistakes, it is always good to do some mistakes. Then only you'll be able to practice more and more. And I'm very happy when I make mistakes, because that is the reason I try to find out, okay, what problem we are actually facing, what did a mistake that I do, and probably I'll not be continuing that mistake as we go ahead. So this becomes my x dot head, and this becomes my y. Okay. Now, after doing this, the most and the important step, that is nothing but train test split. Okay. So here we are going to do something called a train test split. Okay. Now inside this train test split, what our plan is, see, whenever we discussed about the performance metrics at that time, you know that whenever we get our data set, we should definitely do a train test split. We should keep that entire test data separately so that we are not going to touch it anytime, because once we create our model and then once we test with that test data set, we will try to see the performance of the model then and there. Other than that, we'll use this entire training data set to see that how my model is basically performing. Okay, so for doing the train test split, I'm going to use from sklearn.model selection, and here I'm going to basically import train test split. So everything I'm basically using from sklearn, here you have, and here I'm going to use xtrain comma xtest comma ytrain comma ytest. So these are all my features that it is going to create with respect to the train test split. So here you have x comma y, and then here you basically have test size, or I can also push by test size as train size or test size. So let's say test size is nothing but 0.3. That basically means 30% I'm going to put over there, and some random state is equal to 42. I'm just taking any random state. If probably you also take the same random state value, you may also get the same train test split. Okay. So now you can basically check out my xtrain. So these are my entire data set with respect to xtrain, and this is your x test. And similarly, you can check out your ytrain and ytest. So this test data, I'm not going to touch it now. For the prediction purpose and for checking the how my model is performing, I'll be using the test data. Right now, I'll be focusing more on the training data when I use it. Okay. Now, in the next video, we'll start the model training. And before doing model training, one very important step that we really need to do is something called as standard scaling. Okay. Now, what is the importance of standard scalar in this particular case? Understand, guys, if you have understood about the maths intuition behind linear regression problem, we always made sure that we use something called as gradient descent, right? Now, when we are using gradient descent, right, one important thing is that as we, and our main aim in linear regression is to come near the global minima, right? And one important step is that every feature that I see over here, right, this is all calculated with respect to different units. Now, if this is getting calculated with respect to different units, one important step so that our converging of that specific algorithm of the gradient descent will take place faster, we have to normalize, or we have to standardize all these data points to the same scale. Okay, and that should be based on something called a standardized scaler. Okay, so that is what we are going to do over here, a very important step which is called as standardizing the data set. So here I'm going to use from sklearn dot pre-processing, I'm going to import standard scalar. Okay, and here I'm going to basically use scalar is equal to standard scalar, and here we execute this. Now, this is the standard scaling object. Now, all I have to do is that I have to pass and write fit underscore transform. I have to basically pass my X training data set, okay, X training data set, and transform it completely, right, to the same scale. So here I will probably get my X train, okay. Now, similarly, for the X test also we have to do it. But in X test, whenever we try to apply, we don't have to write fit underscore transform, because we are going to make sure that whatever information I have with respect to the training data set and whatever techniques I have applied for transforming it, the same techniques needs to be applied to the test data set. This is done because to make sure that my model does not know much information about the test data set. Okay, so here I'm basically going to write to transform on my X test. Okay, and once we do this, and if I probably try to see my X train, here you'll be able to see all the data points. Similarly, if I go ahead and see my X test, here you'll be able to see all the data points. We don't have to do with respect to the output feature, but definitely for this specific step, right? And whenever we get our new data set, there also we have to probably apply transform and try to do the prediction. Now, these are the steps that we did it. Now, in the next video, we are going to directly train our model. This is super important steps. Again, understand this can be an interview question. They'll say that why do you standardize a data set in linear regression? You just have to say that internally we use gradient descent. Our main aim is to come to the global minima. And to come to the global minima, we have to make sure that all our independent features unit should be in the same scale. Because of that, the convergence will happen quickly. Okay, super important step. So yes, what we are going to do in the next video, we are going to understand how to implement the linear regression algorithm. On this particular data set, my data set transformation is ready. My data set is completely ready. All I have to do is that train my model and try to find out a good accuracy, and also make sure that see how it is performing with respect to the test data. So yes, I will see you all in the next video. Thank you. In this video, we are going to understand now how we can actually do the training of this particular model with the help of this data set that we have recently standardized it and split it into, basically, first of all, we split it into train and test, and then we standardize the data set. So in order to do the model training, again, we have to probably go and import the linear regression model. So for this, I will be going from sklearn dot linear regression sorry, sklearn.linear model, and I'm going to import linear regression. Okay. Now, one thing that I've seen from many people is that if you find out any confusion with respect to finding the linear regression model, all you have to do is that just go and search for sklearn linear regression. So here is the model that we are going to use, and by default parameters here you can see normalize is deprecated over here. So this all parameters you can basically see. It is basically first parameter is something called as fit intercept, whether to calculate the intercept for this model or not. By default, it will be true. We really need to calculate the intercept model. And there are also some parameters like normalize. This parameter is ignored when fit intercept is set to false. If true, the regressor X will be normalized before regression. But we have already normalized it. We have done that. Suppose if you don't want to do the normalization, you can basically keep it as false. But it is always a good practice to basically normalize it. So here you can see that normalize is also getting deprecated. So it is better thing that we try to do it by our side itself. Okay. And here are all the other features. Not much features with respect to linear regression, but when we go and learn about the other algorithms like ridge, lasso, and elastic, at that point of time we'll play with some of the parameters. So here obviously you have understood how to import it from sklearn.linear model. I'm going to import linear regression. So this is my parameter that I'm actually going to use. So here I'm to use regression. Okay, regression is equal to linear regression, and I'm going to just initialize this specific model. Okay. Now, in order to train the model, we have to just write regression.fit on my X train and comma Y train. Okay. So once I do this, you'll be able to see that regression model is created, right? Now, this in short, once we do fit, so on that entire data set, we basically create a hyperplane, because understand here, I have so many features. I cannot say that I'll just be creating a 3D plane or like I'll be creating a hyperplane, because I really have so many number of features that are existing over there. Okay. So quickly, if I really want to print the coefficients, so let's say I want to print the coefficient, because whenever we create a regression plane, right? Whenever we solve a regression problem statement, two important things will be there. One is coefficients, and then the other one is intercept. Okay. So in order to print the coefficients, I will write print, and here I'm going to basically say regression dot coefficients. Okay, and these are my coefficients over here, and this will be equal to all the number of independent features, because for every independent feature I will be having a coefficient, right? I'll be having a coefficient, and this basically indicates, like, let's say the first feature is nothing but CRIM, right? That is what we have seen already. The first feature is nothing but CRIM rate basically means that with the increase, it basically with the unit increase in the CRIM value, there will obviously be this much unit decrease in the price value, something like that, right? So if suppose, let's say, 1,000 crime is increasing, at that point of time, $1,100 will be decreasing with respect to the price, or whatever the unit of the price is there with respect to that specific unit. Okay, so this is with respect to the coefficient, and similarly one intercept you will definitely be having. So here I'm going to write underscore intercept, and here this is basically the intercept over here. Okay, and I've already explained you what is the importance of this intercept also as we have gone ahead. Okay, now what we can do is that if you really want to find out, like, on which parameters this model has been trained, so one more statement, I'll write a comment on which parameters the model has been trained. Okay, so here you can basically write regression dot get params, and you can execute it. Obviously this will be a method, so just try to execute it like this. So here you will be able to see that copy underscore x is true, fit intercept is true, n underscore jobs is normalize is equal to false. Okay, so this all information is there, and this all information you'll also be able to see in the sklearn. Okay, now one super important thing, because once we have trained our model, then we are going to do the prediction of a model. Okay, so let's go ahead and do the prediction with test data. Okay, with the new data also I'll try to show you, but first of all we'll try to do the prediction with the x underscore test that is there. So I'm just going to use regression dot, there will be a method which is called as predict, and here I'm just going to use my x test data. Okay, and this will basically be saved in my regression underscore predict. Okay, so once I execute this, and if I probably write reg underscore pred, here you'll be able to see these are all my predictions. Okay, now one important thing with respect to predictions is that, first of all, whenever we get any predictions, right, we can definitely compare this with the y test information, because for the x test, y test is the true value, right? So how do we check, like, what all information, or how, whether this model has actually performed or not? Okay, so I'm just going to plot some of the important diagrams which will basically help you to understand that, okay, the kind of predictions that you have got from the model, is it good or bad? Okay, so first of all, let's go ahead and let's just plot a scatter plot. Let's plot a scatter plot for the prediction. Okay, for the prediction. So here what I'm actually going to do, I'm just going to write plot dot scatter, and here I'm just going to use if I'm plotting this regression pred. Okay, so what I'm actually going to, I'll just take reg underscore pred comma y underscore test. So now if I plot these two values, or I can also change the order. Let's say I'm going to write y underscore test and reg underscore pred. Okay, if I plot this, guys, here you'll be able to see that the plotting of the values that you'll be seeing, it is basically linear, right? So when this plotting is basically linear, that basically means yes, your model has actually performed well, right? And reg pred is basically your prediction values. This is your truth values. When you see that both the values are almost linear like this, right, that basically indicates that yes, some amount of good information your model has actually done and it is predicting well. Okay, so this is one of the prediction plot that you basically have to do to start with. The another plot is that with respect to the residuals. So here prediction with if I say residuals. Okay, first of all, let me just go ahead and calculate the residual. So here residual is nothing but the error, right? The error with respect to y test and regression predictor. Okay. So if I write y underscore test minus regression prediction, so this will basically give my residual. Residual basically means errors, right? So if I probably try to calculate this and try to execute it. So here you'll be able to see the difference between the y underscore test and regression underscore pred. Now the second plot that I am actually going to do this is the plotting this residuals. Plotting this residuals. Now how do I plot this residuals? Here I'm actually going to use plot this residuals. Okay. Here I'm specifically going to use cbond. So let me use snh dot, and I'm going to use something called as dist plot. Now when I plot this dist plot with respect to residuals, right? Let's say I'm just going to plot this residuals. Okay. And here the kind of plot that I'm going to use is something called as KD. So here you'll be able to see that I will be getting this kind of plot. Now here you can obviously assume that this looks like a normal distributed, but here you can see on the right hand side, okay, there are some kind of outliers and errors. The errors are quite high. And similarly on this particular graph also you can see that there are some points that are really away from all these things, and this looks like an outlier, and obviously the difference will be quite high. This is the same graph that basically indicates our main assumption should be that when we are trying to solve, we should try to get this as a normal distribution. And yes, from this, right, my error, that is my residuals, ranges mostly between -10 to +10 in a normalized format. And here you will be able to, not in a normalized format, here you can see the maximum difference is between -10 to +10, and there are some points that are ranging between 10 to 30. Okay, so I still feel that yes, my model is performing well, because whenever I do this kind of plot with respect to the residuals, I should be getting a normal distribution. So this is the second assumptions that you can probably consider, and you can basically find it out. Okay, now let's go and probably assume one more scatter plot, and this scatter plot is with respect to predictions and residuals. Okay, residuals. Now, if I probably try to plot this, so let's say I'm plotting plot.scatter with respect to regression prediction and my residuals, that is this error. If I plot this, here you'll be able to see that my this different, the when I'm plotting or when I'm doing the scatter plot with respect to the output predicted value and the error, here you'll be able to see there is no such fixed way of telling. This is like scattered anyhow, right? These are scattered anyhow. It is not following any kind of distribution, or it is not following any kind of format, let's say that I can say that, okay, this can follow this kind of shape, or it can follow, these are evenly distributed at every side. I can, yeah, this point will be perfect. This points that you can see between the predicted and the residual are evenly distributed here and there. Some of the points are here, some of the points are here, but most of the points are scattered uniformly, right? Yes, uniformly is the word. I'm extremely sorry. Uniformly is the word. So here you can see that uniform distribution is basically there with respect to the test data and residuals. Super important. Here I'm going to write uniform distribution. Right, so this still looks good. So what I'm actually going to do over here is that I'm just going to consider this uniform distribution and continue. So still this gives me an indication that yeah, your model is performing well. So obviously after doing such a prediction, I have plotted many different kind of diagrams over here just to indicate that how your model is performing. But to be sure, we definitely have to use some kind of performance metrics. Now, what are those performance metrics that we can definitely use? First of all, I'm just going to use from sklearn.metrics, and I'm going to import something called as mean squared error, right? I hope everybody remembers this mean squared error. That was our cost function, right? So I'm just going to say mean squared error, and there are also like mean absolute error, root mean squared error. We'll discuss about all those things, and probably if you really want to also come up with other things like from sklearn.metrics, I'm just going to import root mean absolute error. So, and let's consider this too right now. Okay, and MSC, I can probably print all these things. So my print statement will be having mean squared error with respect to my mean absolute error with respect to my y test and reg pred. This also I'll try to print, and I'll also print mean squared error. And here also I'm going to basically take y underscore test and reg underscore pred. So these values will obviously be able to see over here. Uh, there is also something called as root mean squared error. Now, in order to apply root mean squared error, so here I'll be saying np dot, I think we have something called as square, right? Square root. Okay. I will just apply this on my mean squared error of this specific value. So here also we'll be able to get the root mean squared error. So these are all my values, and always remember that these values will basically indicate how my model is basically performing. Now, apart from this, here we have definitely understood, okay, if I plot the residuals, I'm getting a normal distribution. Yes, with some kind of outliers with respect to the differences, but most of the points that are having the differences is between -10 to +10, okay? And one more performance metrics that I can definitely use is something called as adjusted square, R square, R square, and adjusted square, right? Adjusted R square. So this part I will be discussing in my next video. This is also another super important performance metrics that we can definitely use whenever we are trying to create a linear regression model. Okay. So this is the next thing that we are going to discuss. So I hope you have understood till here. We have understood about the assumptions. So here, after the model training, I'm just going to make some assumptions over here. And with respect to the assumptions, to just understand whether your model is going to perform well or not, you can basically use all these assumptions. But at the end of the day, see, if your data points is highly scattered, right? One important thing you'll be able to understand that obviously just with a single line, right, you won't be able to do that much good predictions. That is a linear line. So linear regression is basically creating a linear, right? Obviously, with that linear line, you'll not be able to just create a better model, right? Because your data will be highly distributed and you will be having a lot number of features with respect to that, right? But again, we have created it. Here we have made some assumptions. Assumptions was basically scattering plot with respect to your y-test, regression prediction, your residuals, right? And how I have also made you understand how should your residuals looks like when we are creating this kind of dist plot. Then how your scatter plot should look like with respect to the predicted models and the predicted values and the residuals and errors. And similarly, we can use mean squared error, mean absolute error, and root mean squared error to find out how your model is performing well. Now, in the next video, which is super important, R square and adjusted R square, we'll try to implement it and we'll try to see what kind of score we are able to get. Okay. So thank you. Yes, I will see you all in the next video. Thank you. So guys, in this video, we are going to check out more performance metrics and we're going to see whether our regression model that we have created is good or not. Okay. So first of all, we are going to use R square and then adjusted R square. I hope I have already explained this in a theoretical understanding. R square formula is nothing but 1 minus sum of square residual divided by sum of square total. Similarly, adjusted R square is nothing but 1 minus R square multiplied by n minus 1 divided by n minus k minus 1. And you should always know that the adjusted R square will be less than R square always, right? So to begin with, how to calculate this? So we are going to import a library which is called as from sklearn.metrics. I'm going to import R square, R2 score, and this will basically be my score where I'm considering the R2 score, and here I'm going to give my y test, comma y underscore or regression underscore predict. Okay, and if I try to print the score, okay, here you'll be able to see that I'm getting 71, which is good enough with respect to the kind of problem statement that we are solving. And more it is towards 1, the more better the score that we are actually able to get, right? Now, the next thing we'll also try to do with respect to adjusted R square. Now, see, adjusted R square, no such libraries there. So we will directly try to implement this particular formula. So here we are just going to copy this code, 1 minus score, okay, the multiplied by length of y underscore test minus 1. So this is my n value, this is my n value, this is my k value, and this is this. So just try to understand it. I've already explained this, and if I execute this, you'll be able to see that my adjusted R square will be less than the R square. So obviously this is the property that needs to happen. Okay. So from this also it looks good. 68% we are able to get, right? So this many number of videos, I've made sure that I explained you about each and everything with respect to this, with the regression model and how to check your performance metrics, different performance metrics like means absolute error, mean squared error, root mean squared error, R squared, adjusted R squared, and finally we have done this. So super way. I would suggest again, just go through it, practice some of the things, and yes, you will also be able to do with respect to new data set. Now in the upcoming data sets, we are going to take more complex topics. We will be doing more EDA. We'll try to do more feature engineering, feature selection, and all. So I hope you like this one. Yes, I will see you all in the next video or next practical session. Thank you. Bye bye. Take care. So guys, in this video, the regression model that we have created, right? We are now going to take up a new data and probably predict it through our regression model and see what output we are able to get. Now in this kind of predictions, we can either get bulk of data or we can get single data points, and we have to probably do the prediction. Already with respect to the bulk of data, like in this particular example, I have taken, in X test data, and probably we have done the prediction and we have found out the, here you can see if you have a bulk data, we can directly use regression.predict X underscore test. But in most of the scenarios, we will be getting single data points, right? Now let's consider over here, if I probably go again back to boston.data, right? So here I have multiple data points like this. If I really want to pick up, let's say the first data point of independent features and do the prediction for this, how will I do it? So here if I write of 0, so here I'm going to get my entire data points. But let's go ahead and see the data point of shape, right? So here you can see it is 13 comma. Now when we made or trained our model, right, we have given that in a 2-dimension, right? So 2-dimension basically means, first of all, I have so many number of rows and so many number of features, something like that. So 2 dimensions will be there. But here, since I see this shape, it is just 1 dimension. So first of all, I'll try to convert this into some other shape. So here I will just reshape this into 1 comma minus 1. Now if I see this and if I probably try to see the shape of it, here you'll be seeing that 1 row and 13 columns. So this is how I have to give my data set. So if I reshape it like this, I'm probably execute it. This is how I have to give my entire data set for my model prediction. So the regression, that model that we have created, and if I write predict dot this entire, let's say I'm just going to give the first data. So for this data points, you'll be able to see that I'm going to get an output of minus 45, right? So if I probably give this all data points for my model prediction, then you will be able to see that I'm actually going to get this much, something related to this. But why I'm getting minus 45? You may be thinking, Krish, this is just a negative value, because we missed one very important step. That is, whenever we get our new data, we have to first of all do standardization. That you have probably missed it. So don't ever forget about standardization. If you remember, standardization over here has some values. Here you can basically see that we have used standard scalar, and this was my object name. So what I'm actually going to first of all do, I'm just going to write scalar dot transform of these values, right? So here I'm basically going to write scalar, because this is what we did in the transformation, right? This is the transformation step. So this the same thing we have to do it for our new data, transformation of new data. So if I write scalar dot transform, and now if I use this entire data set, I will be getting my scaled data set, right? Scale data set. So let's see. Now this is basically my scale data set. Now I have to use the same data to basically do the prediction. So I'm just going to write over here as like this, and this will basically do my prediction. Now here you can see that I'm getting the correct value. So don't ever get confused, because whatever steps we did from the starting, right, all that transformation we also have to follow for our new data predictions also, right? This is super important step. So I'm making a separate video for that, because if you take a new data point, how the predictions needs to be done. So this will basically be your output. So now we will also be seeing in an end-to-end application, we'll be creating an HTML page. We'll provide all these inputs through the form, and we'll get the output and display it in the front, in the website or in any web application as such. So this is how you actually do the prediction with respect to the new data. So I hope you like this. So yes, this was it from my side. Thank you. Bye bye. In this video, now we are going to pickle the model file, the regression model file, so that we can further use this for deployment. Because all these projects that I'll be showing you, at the end of the day, I will be doing the deployment with the help of Dockers and GitHub Actions. So to begin with, what we are going to do is that, first of all, we need to import pickle. This is a very, very important file altogether, because this will actually help us to do the pickling of this regression model. Now, in order to convert this into a pickle file, I will be using something like pickle.dump. Okay, so this will be a dump operation altogether. And what I'm actually going to do, first of all, here, the first parameter that we basically use is an object. Okay, now whatever model that we have actually created, here I'm going to write it down as regression, comma. Now in the next step, like I have to basically say that on which file I'm basically going to pickle this, or I'm going to put this entire object over there. So here I'll be using an open function in Python, and we will be creating a regression model.pickle. Okay. And I'm going to just give this name regression model.pkl, and this should be opened in the write byte mode. So this should also be given in the form of string. So this basically indicates that if this file does not exist in my local folder, and here I have not given any path, so in which folder this file is basically running, in the same folder it will create a pickle file. Okay, and it will open this in a write byte mode. It will put down all the content of this object inside this, and this pickle is a serialized format file, so that it can be deployed in any server, and probably if you want to do the prediction from a web application, we can easily do it. Okay, so here it is. I'm getting an error. Let's see what is as an integer is required, got type str. Okay, let's see what is the problem with respect to this. Okay, sorry, there's one mistake. I had closed this open brackets over here. So here it is now. Now here you can definitely see that where that particular pickle file has been created. Okay, so if I go and click on open, here you'll be able to see regression model.pickle file. Now this pickle can also be loaded, so it can also be loaded with the pickling with this pickle library. So let's see how it can be loaded. So here am I basically going to say, okay, this is my pickled model, and I'm basically going to use pickle.load. We can also load this specific file, and it can load this file in the read byte mode, right? We should always load this file in the read byte mode. So if I write pickle.load, and again here I can use my open function, and I will basically be giving my regression model.pickle file over here, and then this should basically be in my read byte mode. Okay, so once I execute this, now you remember I had basically done the prediction for this value, right? So can we now do the prediction for this value again? So pickle model.predict. If I really want to do the prediction, I'll just paste it over here and just execute it. So okay, one parameter is missing. Let's see where it is missing. I have to close this bracket. Perfect. Now here you can see that I've got the same output here also and same output over here also. So in short, what I have actually done is that once you create your model file, you can definitely do the pickling. You can do the pickling over there. You can save it as a file in your local storage, in the cloud, wherever you want. And this is what happens in the real world scenario. Once we create a pickle file, let's say I'm using an AWS S3 bucket, so I will probably be storing over there, and later on I'll be loading it and I'll be doing the prediction. Okay, so here you can see we can also do the same thing. We can create that into a pickle file, which will basically be storing all this information in a serialized format, all the information regarding that specific model, and then I can again load it, and again I can do the prediction. And this is what we will be doing in the next videos, because now I'm going to create an end-to-end project. I will create a HTML page where I'll have all the inputs with respect to all the values over there, and we will try to use this pickle file. We'll also make sure that we'll dockerize this entire container and deploy it in the Heroku platform, or AWS or Azure. Let's see. We'll go with Heroku. We'll also use GitHub Actions for creating the CI/CD pipeline. So yes, this was it with respect to pickling the model file. Now in the next video, we are going to discuss about how can I convert this entire project into an end-to-end project. And for that, we'll be using Visual Studio Code. So yes, I'll see you all in the next video. Thank you. So guys, till now, we have actually created a model for the Boston house pricing dataset. And we also tested the new data. And finally, we pickled the model file for the deployment. Now we are going to move towards how we can convert this entire project into an end-to-end project itself. Okay. So first of all, now I'm going to use Git. Okay. And a lot of things we are going to see while we are covering all this project. While we create the end-to-end project, we obviously need to follow the industrial standards, So when we are following the industrial standards, obviously we'll be using GitHub. Apart from that, we'll be using CI/CD pipelines. Specifically here, we are going to use GitHub Actions. And then we'll also be using some cloud where we can deploy this entire application. We'll create some simple front-end application as we go ahead in this series. So to begin with, just go to your GitHub profile, guys. And this is what is my GitHub profile looks like. Here, I'm just going to click on your repositories and probably I'll just create my new repository altogether. So here, let's go ahead and create a new repository. The new repository is Boston House Pricing. Okay. So this is what is my repository name. I also need to add a README file. I also require a git ignore file because I will be doing all my coding with the help of Python. So some of the files that are already present with the help of Python, I don't have to commit in GitHub again and again. So that is the reason why I'm specifically using this. And you can probably pick up any kind of license. Let's say that I am picking up some Apache license 2.0. And then finally, I will go ahead and create my repository. Okay. Now this is the first step. Please go ahead and create your own GitHub account. Along with that, create a repository. Now, here you are able to see that, okay, fine, I can see that my entire repository is over here. And whatever code I'm going to write going ahead, I'm going to commit in this repository. Okay. Now, in order to, clone this repository, because I really need to clone this repository in my local so that I'll be able to make a commit onto it. Okay. So in order to make a clone, what all things we can do is that, first of all, just go over here. You'll be able to see local over here. Local is an option. And here you have something called as clone. Okay. So I'm going to click on this. And I have created one folder which is called as end-to-end project. And my first project will be related to Boston house pricing dataset. Okay. So here I'll just open my command prompt. So here you'll be able to see, I can see my command prompt. And then I will go to this specific path because I want my repository over here. So this will go to E. Again, you open command prompt, you open terminal from your Mac or Linux and go to that specific folder where you want to clone that repository. So I will go to that particular folder and then I'm just going to write git clone. Okay. And whatever URL I have actually copied over here. So this entire URL, I'm going to paste it over here. So as soon as I execute this, here you can see that the cloning has actually happened. Now, if I probably go and see my folder, so Boston house pricing is basically here and you can see all your git ignore license file and readme file. Okay. So in short, what we have done is that we have cloned that entire repository. Now from this, whatever files I will probably be creating, whatever things I'll be creating, I will be publishing over there, right? Now, if you remember guys, already in my practicals, you will be able to see that I have actually created one IPYNB file and pickle file, right? So just copy this file back to the same folder over here, which you have actually created. So this two files should also be over here and we will be using this pickle file in order to do the prediction. Okay. Super easy till here. If you find that your git clone is not working, just go to your browser and just download git CLI. Okay. So git CLI can be downloaded for Windows. It can be downloaded for Mac or Linux. Okay. So here you'll be able to see, just go and click on download. So Mac OS, Windows, Linux, whatever is your OS, just go and download it and then it will download an exe file and just continue, click on next, 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 and the installation will happen. If and only if your git clone is not working. Okay. So this is how probably you have done the git clone. Now, the next thing is that we will go ahead and open or download Visual Studio Code. And this Visual Studio Code we will be doing our entire end-to-end implementation in this. So you can go and download for Windows. If you don't want Windows, if you want for Mac OS or Linux, you can select any one of them and you can start downloading and just do the installation part. Installation part is very much easy with respect to Visual Studio Code. Now, once you have downloaded the Visual Studio Code, what you can do is that you can just open that Visual Studio Code. I have already downloaded it. So over here, you can see this. So I will open this. Right now, some of the projects is visible over here. So let me just open the folder. And the folder is nothing but the same location that we are going to go ahead with. So I'm just going to execute this. And here, I'm going to select this folder. Now, over here, do you want to save your workspace content? Don't save. So now you can see all these particular files will be open and available over here, right? So this is my entire project. Here you can also see git ignore file, everything and as such. License is also added. Linear regression model is also added. Regression model.pickle file is also added. Okay. So all the files are there. You can open this and you can check it out. So this is what is the code that we have actually done, with respect to this. And the same code, whatever we had done right in the past, everything is visible and you can definitely do the coding here also. That is also not a problem. And this is basically my pickle file. This pickle file is in the serial list format, so I'm not going to do anything for this. Now, when we are implementing an end-to-end project, what all things we have to do, we'll start discussing from the next video. But in this video, you have seen that how we made sure that we cloned our repository. We created a repository, cloned a repository over here. And in going ahead, right, any commits that I really want to do, I will be doing from this specific Visual Studio Code itself. And for that, you have to probably install git CLI. Okay. So this is it. Let's go ahead and let's discuss about how we'll be working on the end-to-end project in the next video. Thank you. So guys, now I'm quite excited because yes, we did a lot of EDA, we created our model, we converted that into a pickle file. But now is the main thing. And if you know all the steps properly, this will differentiate you from the other people, and you can really be close towards working into real world industries with respect to any projects that you're working in. So I'm making sure that I will follow all the best practices. I'll put up my entire experience and probably create some simple projects for you so that you can actually implement it on a go. Okay. So yes, let's begin. Now, first of all, I will write down some of the steps in the README file, whatever things we'll be doing. I will be updating all the steps over here. Later on, we'll be using Dockers, Heroku and everything. So all the steps I'll be updating over here so that everybody will be able to follow me. Okay. So here, first of all, this is what is my title looks like, Boston House Pricing Dataset. Now, first thing, what do you require? Already, you know that we have done a lot of installations, right? So the first thing is the software and the tools requirement, that is the software and tools requirement. So first of all, as said, you have to create a GitHub account, right? So here I'm just going to write down GitHub account, and the same README file will be updated in the GitHub repository also. So that tomorrow, if you're probably planning for the interviews, if you give your GitHub repository, if the interviewer sees, like, okay, you have written all the steps, to basically create this specific projects, they will definitely be get impressed by you. So here I'm just going to put all my links of the tools and softwares that we are going to use. So first is github.com, definitely. Coming to the next one. The next one that we are going to use for this particular project is VS Code IDE. So finally, you will be able to see, I'm just going to write VS Code IDE. Okay. So here is the VS Code IDE that we are going to specifically use. Let's see why the coloring is not coming over here. I think it will come. And after this, I'm just going to give you all the links from where you will be able to get this, right? So code.visualstudio.com. Now you may be thinking, Krish, why are you writing in brackets and everything? Trust me, this will work. Now see, once I save it, if I probably preview and click on open preview, here you can definitely find out all the things available, right? So all these things I'm doing for that specific reason. Okay, so let me just see why this is not coming. Okay, it should be basically coming in this way. VS Code IDE. Okay, VS Code IDE. Okay, fine. Let me do one more thing. Before this, I also require a Heroku account. Okay, so Heroku account also you require it, guys. So please make sure that you create your Heroku account. Uh, okay, if I'm using a space over here, at that point of time, it is creating issue. So VS Code IDE, I'm going to use it over here. Heroku account, you can basically go with https heroku.com. Okay, so this is my second thing. Third tool, VS Code IDE. Okay, this is my third. Coming to the fourth one, which is super important that everybody should know, is about Git CLI. Okay, so this also I have spoken about it, and Git CLI also you really need to download it. And I'm just going to give you the link for the same. So here is the link. I've basically copied it from there. Okay. Now, if I probably preview it here, let me just open this and preview this. Okay. Open preview. So here you will be able to see all those things. VS Code. Okay. I don't have to provide any space over here. Some issues with respect to spacing. So these are all the things. And the same README file, I'll commit it in the GitHub repository. So this is the first step that you require. My suggestion would be, please go ahead and create your own GitHub account, go to Heroku account and go to VS Code IDE, download VS Code IDE and all. So just to show you how things will go ahead, first of all, everybody knows how to download VS Code. So you can download it from here. You know about GitHub account, sorry, Git CLI, you can download it from here. If you want to create your own GitHub account, just go over here, go and sign up in this repository. Okay, sorry, sign up in GitHub and you'll be able to create your repositories also. Okay, then coming to the next step, which is Heroku, right? So you also have to create an account with respect to Heroku, because this is the cloud platform we will be using in order to deploy our application, and it actually provides you 5 applications to deploy completely for free. Okay, GitHub, there will be also something called as GitHub Action, which we'll be discussing as we go ahead. Um, but these are the 4 tools that we are going to use with respect to our implementation. And everything has been updated over here with respect to this particular file. So let me just quickly open this. Yeah. So here it is with respect to all the things I have updated it. Now, let me just go ahead and open the terminal. So if I probably see new terminal over here, okay, to start with, we will definitely create an environment. Okay, so whenever you start a new project, we definitely have to create our environment. By default, right now it is taking development environment. What I'm actually going to do is that I'm going to create an environment from scratch. I'm probably, because every projects you have to create a new environment and start implementing thing. So let's start and create the next environment from the next video itself. But please make sure that you have all the accounts with respect to this. And the format that you'll be seeing, I'm updating over here in the README file, is basically to see in a better way. Okay. So yes, I will see you all in the next video. So guys, in this video, we are going to create a new environment so that whatever coding or whatever end-to-end projects we are actually creating, we'll do it entirely in that specific environment. Now to go with, right, what I'm actually going to do is that I'm just going to open my terminal. So here is my terminal. Let me click on new terminal. And here you can see that by default, it is going to some specific environment called as development. So let me just go and deactivate this because I don't require this environment altogether. So it will be deactivated. So this entire environment has got deactivated altogether, right? So let me clear the screen. Now, first thing first, let me just open. Here you'll be able to see multiple things like PowerShell, Git Bash, command prompt. Okay. Now everything, like suppose if you are working in Linux or Mac, you can definitely use your own terminal, which will be given over here. But with respect to Windows, here you'll be able to see multiple options so that you can also run commands that are related to Linux or Windows itself. Okay. So what I'm actually going to do, first of all, let's go ahead and take one command prompt. Okay. So this is my command prompt. Right now we are into the base environment. I'm just going to clean the screen. Okay. And here you can see this is the path of my environment. Now the first step after usually what we do is that we create our new environment. So here create a new environment for the project, and it is always a better step that whenever we create a new project we have to create a new environment. So to create a new environment, the command that we are specifically going to use is something called as, and obviously if you are using Anaconda, I think this is the command that you should use. So conda create -p v env, that is the command, that is the environment name. And then Python that I'm actually going to specifically use is something called as 3.7, because I feel with the help of 3.7 we'll be able to do all those things. Okay. And this -y basically says that, because see, if I don't use this -y and if I probably execute this much, it will basically again ask me a confirmation whether I should go ahead with the installation or not. So instead of again clicking over there as y, what I'm doing is that I'm giving -y as over here itself, so that it takes that yes prompt from here itself. Okay. So this is what we are going to do. And now I'm just going to execute this command over here. And this in short will basically create my environment that is over here. So to begin with, what I'm actually going to write, conda create -p venv. So this is my command prompt name, sorry, environment name, not command prompt name, 3.7 -y. So once I do this, here you'll be able to see my installation will automatically happen. Now here you can see that it will ask for one confirmation here. Since I've given -y, so all the installation will take place. Okay. So here you can see that venv environment is getting created, right? So here itself you'll be able to do all the specific work. Okay. So this will probably take some time, but here we are actually using this. We are doing this entire. We are creating our new environment, and whatever project we basically write over here, it will be created in this specific environment also. Okay. Now, the next thing what we have to do is that activate the specific environment. Now, in order to activate this specific environment, here you can see that you can just write this specific command, or what you can also do one thing is that you just write something like this: conda activate venv. And since venv is over here itself, so I'm just going to go inside this folder. So here you can see that now this particular environment has got activated. So let me make my face smaller. So here you can basically see this environment has got activated altogether. Okay. So finally we are inside this environment. Okay. Now whatever files we create, whatever things we do, we will basically be working within this particular environment, and we'll be committing our code with respect to this. Okay. So again, if you open any file like this, here also you can set it directly. So venv, this one is there. You can see this. This is the project that we are going to do. So I'm just going to set this over here and save it. Okay. So like this also you can basically set it and you can execute it by your wish, independently you can basically execute it. So this is how we basically create this. So create a new environment is the first thing. So I've written the command over here. You can also see it by a preview option. Okay. So in the preview option, you'll be able to see that this is my second step after this, creating a new environment, and here you will be able to find it out, all the information. Okay. So now in the next step, what we are going to do is that we are going to start writing our code. Okay. And over here, we are going to make sure that once we create this README file, or once we create this environment, you can start writing our code. Now, one important thing that I really want to do is that, first of all, and probably this is a small step, so let me include in this video, is to create a requirement.txt file. So requirements.txt file I will be creating over here. And in this, whatever libraries you require, like sklearn or any kind of libraries that you require, you can basically write it over here. Like if I take an example, like when I'm creating this end-to-end projects, I will be using a library which is called as FLASK. So FLASK will be the library that I'm actually going to use. And what we are going to do with respect to FLASK also, we will be installing this. One more library is sklearn, since we'll be using machine learning. Suppose if you want pandas, you can use this. If you want numpy, you can use this. Matplotlib, you can use this, right? All these libraries will specifically be required. So I'm going to import this. Flask will be capital F. So these all requirements. Now, if probably I want to install this library, all I have to do is that write down a command over here as Python, uh, Python, sorry, not Python. It's just like pip install, okay, -r requirements.txt. So this will be requirements.txt. So once you install this, you will be able to see that the installation will take place. So all the installation will be taking place from here itself. And within this environment, you'll be able to see those libraries will also get installed since I am inside my VNV environment. Okay. So here you can see that all the installation is basically taking place. Okay. So any libraries that you may probably be requiring in the upcoming future, you just need to write it over here and we'll do it with the help of pip install. Okay. Now this is perfect. So this will take some amount of time, but anyhow, the installation will take place. Let's consider that the installation is taking place. So I'm going to pause the video now. In the next video, we are going to learn about some more things that we really need to do the setup as. Okay. So yes, I'll see you all in the next video. So guys, now you have seen that you have created your environment. You have also created requirement.txt file. So anytime, probably you want to do some kind of installations with respect to any packages, you just have to write pip install -r requirement.txt, right? Now till here, everything is fine. Now, one thing that every code that you write over here, we really need to push this code to our repository, to our GitHub repository, which we have actually created initially. Now, in order to do that, we have to configure our git CLI with our GitHub repository so that with the help of commands, we'll be able to push all these files. So how do we go ahead and do that? So first of all, we really need to set up some configuration. You have created your GitHub account with some email ID, right? So we have to set that email ID in our git CLI. In order to set it up, first of all, just go and write git config. And when you write git config global user.name. So two things you have to set up. So let me just again clear it. Okay, so one is git config minus global. So we are going to set up the entire global user.name. So if I execute it, I have already configured it. So here you'll be able to see that I'll be getting Krish Naik. But if you want to configure it in a new type, so just go ahead and write your name, whatever user.name you want to write over here. So in this case, I can basically write Krish.Naik, right? Krish Naik. So once I execute this, you'll be able to see that it'll get executed successfully. Now, anytime I will try to just call this user.name, you'll be able to see that I'm getting Krish Naik. This is the one configuration that you have to do. The second configuration that you really need to do is user.email. Now, user.email here, you should basically assign the same email ID through which you have actually created your GitHub account. So in my case, it is krishnaik06@gmail.com, right? So here, this is my GitHub account email ID. So what I will do is that I will set up my user.email to this. Now, why I am specifically doing this? Because later on, when you commit your code or when you commit your entire repository into the GitHub account, automatically it will ask you to give the password for this email ID. At that point of time, you can just type down the password for the first time and automatically it will get saved. Okay. So again, I'm not going to execute this because I have already done it, but remember the command git config --global username and then user.email. Okay. This is perfectly fine. Now I'm just going to clear the screen once again. Now you can see over here that I have created so many files. I've created requirement.txt, regression model. I want to commit all this file. And in git ignore, you also have to make sure that whichever folder or files you don't want, you can actually give it over here so that that files will not get committed into the repository. So already we have done that, and by default, some of the files it has already written. If there is any specific file you don't want to take over there, you can basically write it down. So it is going to ignore that specific file. Perfect. Now what I'm going to do, whatever code I have written, this files, IPYNB file, PKL file and all, I need to commit it in the repository. So let's go ahead and how to do it. The first step that is super important to start with is that I need to, whenever we basically write this, or whenever we go ahead in committing any code, there are some series of steps that we need to follow. Obviously, you can go ahead and have a look onto the documentation in Git CLI, which definitely will be easy. But most of the time, what steps we definitely follow, that is what I'm actually going to show you. A detailed implementation part you'll be able to understand through this. Okay, so to start with, let's say I want to add any file. Okay, add any file that I really want to put it into a repository. So here I will basically say git add. Let's say I want to give my requirement.txt or readme file or any file as such. So git add requirement.txt. When I press enter, here you'll be able to see that this file will get added. So if I probably just update git status, so here you'll be able to see that, okay, modified this readme file. You can see this new file is requirement.txt, right? All the information regarding this file will be given. The untracked file is this, right? But here you can see that the new file is requirement.txt, which we are going to push it into GitHub repository, and that is the file that I have added over here by using this git add requirement.txt. But there are still some more files, right? readme.md. This is modified because readme file was already created in my GitHub repository, and there are two more files that are left. Now, if you want to use just one file, that is fine. But if you want to add all the files so that we push up in the GitHub repository, I can basically use git add dot. When I say dot, it is going to basically add up all the files. Okay. Now if I probably see git status, you will be able to see that all these files are basically been added. Okay, this is the ipynb file. There were some warnings with respect to the name. That's fine. That is not a big issue. Okay, now I'll clear the screen. So guys, now we have added all the files that needs to be committed to the repository. So the first step, obviously we have added it. Then the second step, we really need to do something called as commit. Commit, what it does is that from our local, it basically pushes it to the staging environment. Okay. So here, let me just open our browser and just let's search for git commit. Okay. And always make sure that you follow this Atlassian Git tutorial document. It is an amazing document altogether. So here you will be quickly able to see that, okay, you have commands like git commit, commits the stage snapshot. This will launch a test editor prompting you for a commit message. Okay. So I will probably not use this because I also want to give the commit message directly into the command. Git commit -a, commit a snapshot of all the changes in the working directory. This is also fine. We will try to use this particular command, git commit -m commit message. Okay. So here you can see a shortcut command that immediately creates a commit with a past commit message. By default, the git commit will open up the locally configured text editor and prompt for a commit message to be entered. Passing the -m option will forgo the text editor. Now, this is super important, guys. So what I will do is over here is that I will just go and open our VS Code. And here, you know that through git status, we are able to see that what all file needs to be pushed to our repository. These all files are there. Now I'm just going to add git commit, and the same command I'm going to use, which is called as -m. So here you could definitely see what is the command -m, and along with that we will be using something called as commit message. So here what I'm actually going to do apart from this, I'm just going to write my commit message and I'm going to say this is my first commit. And this commit includes, or I'll give a very meaningful things. This commit includes requirement.txt and readme file. Okay. So I've written a commit message over here so that anybody will be able to understand it, and I'll press enter. So here you'll be able to see that it is basically asking for me a very important information. First of all, please tell me who you are. See, for the first time I told you, right, we have to set up this global user.email. Now you can see over here, you can see all this information is given. Now I will go ahead and write this all the information. And it is also saying that unable to auto detect email address. This is also perfectly fine. So what I'm actually going to do, I'll just copy this and I will go ahead and write git config. And this you have to do it for the first time. Okay. After that, you don't have to do. Then I will say global user.email. Okay, user.email. And here I'm going to set my email to krishnaik06@gmail.com. Okay. So once I execute this, here you'll be able to see that is set. Now, similarly, I want to do it for my user.name. User.name, I will be using Krish Naik. Krish Naik. Okay. And press execute, enter. Okay. Now this is done. Now I'm again going to use this particular message, get commit -m. This commit includes requirement.txt and readme file. So once I execute this, now you can see that the full files has been changed. 3167 insertions, one deletion, all this information has been pushed and obviously you can check out this information over here. Shortcut commands that immediately creates a commit with a past commit message. By default, this. It basically commits a snapshot of all the changes in the working directory. Okay, this is what we are basically doing. And again, guys, since this is not a dedicated Git, so it'll be a very big course if I go and probably explain about each and everything in Git. But most of the time, what does a developer do? That I'm actually trying to cover up. Okay, so here it is. Now the final thing that we have to do is basically git push. Now similarly, you can go and search for git push from the documentation. So here you can see Atlassian git push. So here you can see git push remote and branch. Okay, so these are the two information that I have to give, remote and branch. Now in order to give this remote and branch, first of all you need to understand what this remote and branch is all about. Okay, so first of all, if you go over here, you'll be able to see this is my main branch. So I have to definitely push over here in the main branch. Right now, still the code is not nowhere over here, right? It is still in that specific staging environment and I need to push it from here. We have already done the commit and it is ready to be pushed to this particular branch. Now, if I really want to push to the main branch, now I will go ahead and write this specific command over here. Okay, let me first of all clear the screen now. So I will write git push. Okay, right now whatever commit we have made, okay, let's say it is in a specific environment. That environment will be something called as origin, and now from the origin I'm going to push it to the main branch. Okay, so once I write this, you'll be able to see that automatically all the push will happen. But before that, it will also ask you for this kind of option. Okay, and you just need to sign it with your browser to give the access to the push. So here you'll be able to see I am clicking on Chrome. Automatically this thing will happen and I'll be getting a successful message, let's say. And over here you can see that the total push commit has basically happened, right? So this is how the commit basically happens. It just asks for this kind of confirmation. Now if I go back to my repository and if I reload it, you will be able to see all the files are updated. Along with that, you will also be seeing my readme file. So this is perfect. Till now we have done the commit, and in the commit, again remember there are 4 important steps. One is we add. Okay, so again you just go and search for what does git add do. So git add command. Okay, there's 3 commands we will specifically using a lot. So what is the git add documentation? It will basically add it. So here you can basically see all the information regarding git add. This git add command will not add ignored files by default. If any ignored files are explicitly, this is there. After that, we will be doing the commit. It basically creates a snapshot of all the changes in the working directory. It commits the stage snapshot that needs to be pushed to the repository, and then finally git push to which repository we are pushing. Remember that once we do this git commit, right, it is basically going to take from the stage environment and put it in something like origin, right? So that is the reason we wrote git push origin to main. Okay, and finally when we do git push, here you'll be able to see that all the information has been pushed over here. So finally you'll be able to see successful GitHub repository which have all these files. Now in my next step, what I'm actually going to do is that I want to create an app.py file. I will create a front-end application. I'll use this pickle file for the prediction purpose, and then I'll be able to get the output. So that is what we are going to do in the upcoming videos. So I hope you like this particular session. This was it from my side. I'll see you all in the next video. So guys, so many steps. We have configured all the tools. We have made sure that we can now commit to the GitHub repository. Everything is perfect. Now it's the time that we build our end-to-end application. These are all the good practices that we follow. So let's first of all create amazing app.py file so that it will help us to build an application wherein we can take an inputs, and based on that, for my pickle file, I'll be able to get the output. So to begin with, what I am actually going to do quickly, and all the code I will try to show you by writing here itself. So I'm first of all going to create an app.py file. And once we create this entire thing, we'll also do the deployment in Heroku platform. So let's go ahead. First of all, let's go and quickly import pickle file. Now, pickle file is important because we require pickle file to unpickle this or load this particular, sorry, not unpickle, but load this regression model pickle file, right? Then I'm going to import from FLASK. I'm going to import FLASK because here we are going to use a FLASK library, and FLASK is basically used to create web applications, lightweight web applications. So definitely this will be more than sufficient. Along with FLASK, I'm also going to use request, and then I'm also going to use app. Let's say app, comma, JSONify. I'll talk about all these things, why it is specifically used as we go ahead. And then I'll also use something called as URL underscore for and render underscore template. So all these things will be using right now till render underscore template will be using all these things. Okay. Now, these are some of the applications we have already imported it. Now, what we are going to do is that quickly, and first of all, let me just hide this and let me make the screen a little bit bigger. So this is imported. The next step is that I'll also be importing NumPy because I required NumPy, and import pandas. Okay. Please make sure that you have all these libraries written in your requirement.txt file. Otherwise, you'll be, because initially we'll install all these libraries in our new environment, and then we can go ahead and probably import it over here and start coding it. Now, the first step is that I will try to create my app, and here you'll be able to see I'm using my FLASK, which will be underscore name. Okay. So here some amount of FLASK information is also required. And here you can actually see that I've actually created a basic FLASK app. And here underscore name is nothing but this will be the starting point of my application from where it will run. Okay. So here we are defining a FLASK app. And then the first step will be that I will try to load my pickle file. So pickle.load. I know what is my pickle file name. So I'm going to write open function over here. Obviously, you know what is your pickle file name. So if I go over here, you'll be able to see reg model.pickle is your pickle file name. So here I'm going to basically write reg model.pickle file. So in short, we are basically opening this pickle file in the read byte mode, and then we are loading this, right? This is how we are basically done. So this entire pickle will be in this particular model pickle. So let me name this model pickle as reg model, that is a regression model. So here, fine, we have loaded the model. Let me write down the comments, load the model. The same thing that we did it in our Jupyter notebook, if you remember, right? In Jupyter notebook also, we have loaded in this specific way. Now, in Flask, what we do is that we basically create our app.route. So here I'm going to basically write app.route, and this app.route will have the first route, right? The first route, you can just say that this, like the localhost, the URL, and slash, if I basically say I should definitely go to my home page. So here I'm going to create my home page as my definition, and this will probably return HTML page. And let me write this HTML page as render underscore template, and here I'm basically going to write home.html. Okay. So this will basically be my render underscore template and home.html. So home.html I have not yet defined, but just consider that this will basically be my HTML page where I can probably say welcome everyone, something like this. So by default, once I hit this Flask app, it is just going to redirect to the home.html page. Okay. And that is how we basically go with respect to Flask. Okay. And then we have app.route. Now we are going to make sure that we create a predict API. So for creating predict API, what I will do is that I'm just going to create an API wherein using Postman or any other tool, we can send a request to our app and then we can get the output. So for this, I will be writing /predict underscore API. So this will be my API that I'm going to use. Apart from this, I'll also be using something called as methods is equal to post, right? So this will obviously be a post request, because here from my side I'm going to give some input, and that will actually capture the input. Then we will go and basically give that input to our model, and our model will give the output, right? So here I'm going to basically write the definition as predict underscore API, and this will actually help us to do the prediction with respect to this. Okay, now quickly let's see what code we will be writing over here. And you may be thinking, Krish, how you are getting all this data, all this code automatically over here? Guys, I use an amazing extension in Visual Studio Code that is called as GitHub Copilot. So GitHub Copilot, as an influencer, as an open source contributor, GitHub has provided me for free. You can also request for it, from the GitHub itself. So first of all, what I'm actually going to do is that I'm going to write data is equal to request dot JSON, and here I'm basically going to use data over here. So what this basically indicates that whenever I hit this predict underscore API, then what will happen is that the input that I'm going to give, I'm going to make sure that I give it in a JSON format, which will be captured inside the data key. Okay. So from here, as soon as I hit this API as a post request with this information, whatever information is present inside this data, we are going to capture it using request.json, and then this will get stored in this data variable. That is what it basically does. Okay. And I can also print this data so that you will be able to see that same information coming over here. So now once we get the data, the first step you remember in our linear regression, what we did is that we first of all did standardization, right? So if I probably open my linear regression ML implementation file, so here if I go down, you will be able to see that we have performed something called as standardization. Let me just zoom out a little bit. So here, if you probably see, after the train test split, we did something called as standardization, right? Now, during the standardization, we forgot to basically, uh, import or transform this particular standardization into a pickle file, because the same pickle file we will be using here also in our app.py. Already we created a pickle file for the model, but not for the standardization. So what we are going to do quickly is that we will execute this entire file again. Okay. And quickly from till that particular line, we'll create a pickle file. So what I'm actually going to do over here is that quickly let's go ahead and execute it. So here quickly I'm just executing it without thinking anything, so that I will be able to get the pickle file. So let's go ahead and let's do that. So here it is, here it is, here it is, here it is. So train test split is done, and then finally we go to the standardization and we do the scalar.fit transform on xtest, xtrain and xtest. Now this is the code that I did not write at that point of time, and probably I wanted to convert into a pickle file itself. So finally, I'm going to execute import pickle.dom scalar open scaling.pickle with the write byte mode. So once we do this, you'll be able to see now in my local folder, there will be a scaling.pickle file. Perfect. And remaining things, I don't want to do it because I already have the regression model.pickle file. Okay. Now, what I am actually going to do is that now we are going to take this particular data, first of all, get transformed into my pickle file. Basically, my scaling.pickle will transform that or standardize that entire data, and then we'll finally do the prediction. Now, before we go ahead, first thing is that once we get the data, this data, when we are passing in, when we are getting it from JSON, right, it will be basically in the key value pairs. So if I probably write print data.values, right? So if I do data.values, I am going to get the dictionary values over there, whatever values it said. But this will not be sufficient, right? I have to first of all convert this into list. So if I get these values and convert this into list, so I'll be getting a single list over there. Then after this, that with respect to the pickling that we did in the regression model also, right? We have to do the reshape for that, right? Now, in order to do the reshape, after converting this into n list, I'll also convert this into np.array. And this array will then, I will be doing the dot reshape, and dot reshape will be done with respect to 1 comma minus 1. The reason why I'm doing 1 comma minus 1, because I'm just saying that, okay, this is a single data point record that you're going to get, and now you have to probably take this up and do the transformation. Otherwise, this transformation, whatever standardization we are using, it will always expecting a single record with so many number of features based on our data set, right? So once I probably print this, I will be able to get it. Now the same thing, what I will do is that I will pass it through my scaling model. But before that, I'm going to import this, right? So here I have written a code scalar pickle.load open scaling.pickle in the read byte mode. So once I have this scalar, all I have to do is that I will convert my new transform data is equal to scalar, sorry, it is callable scalar dot, right, transform function. I hope everybody remembers. And then I'm going to pass this entire thing like np.array this reshape to 1 comma minus 1. So here you can completely see that I'm getting that same thing, right? Data dot values reshape 1 comma minus 1. So once I do this, I will get a new data that will be transformed. And finally, you'll be able to see that if I apply my regression model, so this regression model reg model dot, if I do the prediction with respect to this new underscore data, I will be getting my output. And finally, here you'll be able to see that I will just print. You can also print the output if you want, so that you can also see over here. So output, this will be in a 2-dimensional array. So I'll be taking the first value and I will return from here by using JSONify with respect to output is equal to output of 0, right? Since this is a 2-dimensional array, that is what we got with respect to the regression model also, right? Final output, what did we get? You could see over here, it is a 2-dimensional array. So I have to write array of 0, then I'll be able to get that specific value, right? So same thing I've done over here and created my predict underscore API. Now, finally, here you'll be able to see in order to run this, I will basically write if underscore underscore name underscore underscore is double equal to underscore underscore main underscore underscore. Here you'll be able to see that I will be writing app.run, and this will basically be in the debug mode. I'm just saying that debug is equal to true so that I can be able to debug it. So perfect. This is the entire code that we are going to run. Remember this underscore predict underscore API here, we are just using this as an API itself, right? So that API part we'll be doing with the Postman, which I will probably show you in the next video. One more thing that I did is I missed out is this render template. Whenever we go to the home page, right, it should redirect to us to the home.html, and this render underscore template in Flask will look at a template folder. And right now I don't have any template folder, so I will go ahead and create a templates folder, and inside this I will create a file which is like home.html, right? So here, let me just for the testing purpose, I will write h1 over here, and let's say I'm going to basically call something like hello. Okay, hello world, just to see that something is coming in the home page. Later on, what we'll do is that in the same Flask app, I'll try to create an HTML page over here. And then from here, we'll try to transfer the data and get the output. But currently, what we did is that in the app.py, we created an API, API in short, predict underscore API. And this API, I'll try to call it. Okay. Now, this is the entire coding with respect to this. Now, what I'm actually going to do is that in my next video, first of all, I will download Postman, and then I will run this file, and then we'll try to do the prediction with Postman. Okay. So, and this data JSON needs also to be created. Okay. That I'll show you in my next video. So I hope you have understood it. If not, please keep on practicing. This is the code that we really need to write. Basic amount of Flask idea you really need to have. Okay. So I'll see you all in the next video. Thank you. So finally, guys, we have done all the coding, and again, all the step-by-step process by using Git and all we have seen. We have coded the entire web application, and now it's time to basically run. Let's see whether we are going to get any kind of errors. If you're able to get any kind of errors, then again, we'll try to fix it. But if we are lucky enough, then it'll start running it. Okay. So let's go ahead and let's open the terminal. So here is my new terminal. So I will just go to my previous terminal itself. So by default, I got PowerShell. I'm just going to go to my command prompt. It is still inside my venv environment. So let's go and run python app.py. So once I run this, you'll be seeing that you have to run in this way, right? Python app.py. And this is your IP, which you'll be able to see 127.0.0 500, right? So I will click on this, and here you can see hello world you are able to get. Perfect. Now the thing is that I had created an API right over here. So here you can see that I had created an API, and the API name was nothing but slash predict underscore API, right? So what happens if I just execute this slash predict underscore API? Obviously it is not going to run because method is not allowed. Method is not allowed for the requested URL. Why? Because the method is post. So we have to give some information, some post from the client end, some information. What is the information? That data it is looking at. So for doing this, one thing we are going to use is something called as Postman. So please go ahead and install Postman. So you can go ahead and click on Postman download for Windows. So once you go and click over here you will be able to see something like Postman. Windows bit 64-bit, you can download it and you can install it. And again, installation is very simple. After you download this, just click on this, you'll be getting an exe file. Okay, and you can start the installation. So here you can see it is 143 MB file which is getting downloaded, and you can start the installation just by clicking next. Now once you install it, here you'll be able to see something like this. Okay, I have created a lot many, but it's okay, not a problem. So what we can do is that just go and click on the first one like this. And first of all, what request you are doing? It is a post request. What is the URL that you have to write? You have to basically go with 127.0.0.1:5000 slash predict API. So this is what you are getting from your local address, right? Then let's compare with respect to the body part, right? In the body part, the type of data that you're going to give is specifically JSON data, right? So here you have different things like form data, you have raw, you have this, you have binary. Now what I'll do, I'll go and click on raw, and here I will convert this data into JSON, right? Now, how should I give my JSON data? My JSON data should be with some key value pairs, right? So first of all, I will go over here. I've made one JSON data over here, and then I will just try to paste it over here. Now see this. Now this is what I'm giving as data as my main key. And inside I'm going to give all my features values. Okay. So these all features I'm actually going to give it to my model like CRIM, ZN, and I have initialized some values. Okay. Here, any values you can put. Okay, indus, cache, nox, rm, like this, and make sure that this is a valid JSON. How do I check whether this is a valid JSON or not? Just go over here, click on JSON int or JSON validator. Here you'll be able to see the first link, that is JSON link, and just go and do this and just click on validate JSON. So here you will be able to see this is absolutely a validated JSON, and it is quite accurate. Okay. So I'm going to go again back to the JSON, prepare my data like this. You can put up any values over here. And here you can see that this is the post, this is my API. I'm just going to go and hit on send. Once I hit on send, I should be getting my response as an output. Okay, so once I click on send, now here you can see I am getting my output, that is 30.08. So this is the output that I probably got from my predict underscore API. So as soon as I hit this predict underscore API, it went over here, it picked up all the data, then it converted this into an array, right? It converted this into an array. It did a reshape of 1 comma minus 1. It transformed it with using scalar.transform, and then it finally predicted it, and it JSONified this output, and it gave this output in my Postman. So like this, you can probably try with different values. Let's say if I change this value to 31, and if I just send it, here you'll be able to see that the value has changed. Similarly, if I make this as let's say 1.31, if I go and send it, here you'll be able to see 30.5. If I probably say the crim value is somewhere around, I'll make it as a larger value. So let's say 7832. If I send it here, you can see some values changing. The price of the house is basically changing. And this is how you basically check with the help of Postman. Super fine, because your project is absolutely working, and it is working in an amazing way, right? So this was the thing that we basically did. Now, one final thing that we are going to do over here is that make sure that we commit everything into our repository, right? So if I really want to cancel this running, so I will just write Control Z. Okay, just a second. So here I will just click and Control Z or Control C. Just make it as Control C, and this will get closed. So now clear the screen. Now all I have to do is that add all this code right over here. So first of all, again, remember what we did. We did git add dot. Okay. And then probably we can see that what is the git status. So git status, here you can see all these files has been modified. It's fine. Let's go ahead and commit it, right? So next step is that we write git commit minus m. If you remember all the steps here, we are going to basically write, this is the commit. This is the commit for web application, right? Web application. And then I am basically committing it. So here you can see all the commit has basically happened. And final step is basically to git push from origin to the main branch, right? So once we push it, here you'll be able to see all the pushes basically happening. Perfect, it has done, completed. Now I'll go to my browser. Let's see whether it has been updated in my GitHub file or not. Now here you can see that I'll just go and reload it. Okay. So here all the files has been updated. I'll also make sure that I'll update all the readme file, what all steps we did. You'll be able to find out in the repository. If you really want to see all the commits that has happened, just go and click over here. You can see 3 commits are there. This is the commit for web application. This was the recent one. So here you can basically check out browser repository at this point of time. So this is the repository that it looks like. You can also make sure that you can click what are the commit details over here, what all file has got added, what all code has got added, everything has been added over here. You'll be able to find out all the information, right? So this is how you also check with respect to all the commits that you have done. Okay, now this is perfectly fine till here. Now you'll think of deploying this into a cloud. Once we deploy this into a cloud, then we'll be Dockerizing it, then we'll be using GitHub Action. So there are many things that we are going to learn as we go ahead. Be with me, guys, because one project, if you're able to do properly, all the projects you'll be able to do it. Okay. So thank you. This was it from my side. I'll see you in the next video. In the next video, we'll try to see how we can actually deploy it. Thank you. So guys, in our previous video, we have actually created an API, which is like predict underscore API, which was a post request, and we were collecting the data using Postman. And based on that, we were giving some kind of output after we are passing it through scalar transformation, that is standardization. And apart from that, we are also passing it through the regression model, which is basically giving me the output. But instead of just creating in the form of API, why not just create a small web application wherein we just provide the inputs, we submit the form. As soon as we submit the form, we basically take the data over here and do the prediction with the help of the model that we specifically have. So let's go ahead and let's try to create this. So what I'm actually going to do is that I'm going to first of all say app route. Okay, so app dot route, and here I'm going to create my new function, that is /predict, basically a new method altogether, and this should be actually a post method. And then I'll define my definition, like definition predict, and this is obviously a post method. Now see guys, what I will be doing is that, let's say that we will be having an HTML page, and from that HTML fields, what we'll do is that we'll try to give up all the values, all the input values from a specific form. So we'll create a form which will probably require to give inputs from the user, and those inputs will basically be all these inputs that are actually required. If I probably go and see all the inputs over here, you'll be able to see the target column like CRIM, CRIM, ZN, Indus, Cache, Nox, RM, Age, this, that. So we will be giving all these values through a HTML form. And from that particular form, we will try to get the data over here as app.py. Again, from that form, it will be a post request. Okay. So let's go ahead and let's try to see how to do it. Okay. So first of all, I will just go ahead and get my data. And for this, I'll be using one important thing that is called as request. Obviously, you know that we have imported something called as request over here. So we will be writing request dot form dot values. So when I specifically write like this, so whatever values we are filling in that form, we'll be able to capture it because all the information will be present in this request object. Very simple till now. And then I will try to convert this into float value. So float value, why? Because all those values needs to be given as a float with respect to the model. If we give integer, that is also fine, not a problem at all. But it is good that we are actually making it float. So what I am doing is that I am running a for loop for every values inside this request.form. We are just going to convert that into float, and finally we get in the form of list format. Okay. Then what we do is that we basically create our final input, as this final input will be using scalar dot transform again, because we really need to do some kind of transformation. So scalar dot transform, and here I'm specifically going to use np dot array. Okay, so here it is basically like np dot array, and I have to make sure that whatever values I get in this data, I have to reshape it. Okay, so dot reshape with 1 comma minus 1. So all these values are there with respect to my final input, and then we will go ahead and print our final underscore input. Okay, and this will be my final underscore input, just to see that how my model is basically coming. And then finally I'll be using my regression model dot predict to predict this specific final underscore input. And we know that we will be getting an array which will be of 2 dimensions. So I'm going to just take out my first value, which will basically give me the output. So here is my output, and finally I will be returning, and I will use something called as render template. This is super important in Flask, where I will say that, okay, fine, I'm going to render a specific HTML. Over there, I will redirect it to, let's say, home.html. And in that home.html, I will be keeping a placeholder, which is like prediction text. So let's say I will be keeping a placeholder, which will be like a prediction text. And here I'm basically writing the predicted house price is. Okay, I'm giving a message, or I can basically say the house price prediction is this specific value. Okay, this specific value, that is format dot output. Okay, so what it is going to do is that when after we get the output, what is going to happen, we are going to render the home.html, and it is going to replace this placeholder. So there will be some kind of placeholder in that HTML page, and we are basically going to do the house price prediction is some output, and I'm just going to replace this particular value with the output that I'm getting. Very much simple, and this is the entire predict function. Now what I will do is that one super important thing, let me save this. You will be seeing that initially I created this home.html. Now I have made some changes in home.html. Now guys, it is not important how to design the home.html, but here what I have done is that in a short way, I've created a form. Okay, and this will basically go and hit this predict function that I've actually created in this slash predict. Okay, and here are all my input text. So this all input text I'll try to fill, and these are all my input features. Okay, not that important. See, HTML is not that important for a data science. If you know, that is well and good. Basic HTML is more than sufficient to just create this front-end application, right? And then finally I have my predict button, right? So inside this form, when I click on this predict button, it will go to this particular URL, that is predict, and in short it will basically call this slash predict, and then entire this function will be called. After that, you'll be seeing that where does this output get displayed. So if you go decide, right, there'll be something called as a placeholder, which is in double flower brackets. So the same prediction underscore text I'm actually using as my placeholder. Okay, so let's go ahead and let's try to see whether this will run or not. Finger crossed, and let's see if even though we get any kind of problem, right, always make sure that whenever you are in the command prompt, you have to be in your venv environment, and then only you try to run it. So guys, in order to run, again, I will go ahead and have a look on Python app.py. Once I execute it, you can see, okay, some error. Okay, I did not save this file. Let's see. Now it should be working fine. Python app.py. Now here you'll be able to see the URL is done. So I will just go and click this URL. Let's see how my URL will look like. And if I open it here, you'll be able to see Boston house pricing prediction, and these are all my features with predict. A simple HTML just to practice some of the things. That is the reason I've created this. So here are my values. I will just place it at any values you can select it, guys. It's up to you. I have just tested with some of the values before. So I'm just going to place some values. It is up to you. Whatever values you want, you can actually place it. Okay. And then finally, you can see that once I click on this predict button, right? So once I click on this predict button, you'll be able to see this home.html. When we are specifically clicking on this predict button, it is going to go ahead and hit this predict URL in app.py. So here is my predict URL in app.py. Here we are going to basically take up all the values that we are going to get from that form. And then here I'm going to convert this into an array with this shape. and then we are finally transforming it, and then finally we are predicting it and getting the output, and we are displaying the output in the same home.html with this new text. Okay, that is what we are doing. So let's go ahead and click predict, and let's see whether we get the output. And something has happened. If you go down here, you will be able to see the house prediction price is somewhere around, house price prediction is 13.92. Superb. So here you have basically created a simple front end application, and with the help of just click on predict, you are able to interact with the model and you're able to get the output. So guys, here you could see that I'm getting a good predictions over here. Again, I just put up some random value. You can test with other different values and see what the prediction is. Now, when we know that, okay, my application is working fine, what I'm actually going to do now is that I will press Control C, come out of this clear screen, and I'm just going to do the commit over here. So I'll write again git.add, and here you'll be able to see, if I probably see the git status, you'll be able to see some updated. So I have added or modified this many files. Perfect, not a problem. And then I will just add git commit -m, and I'm going to give the message, and here you can see the web app is ready. Okay, and finally just execute this, two file changes, and then finally I'll just do git push along with that from origin to main. So here it is, the entire git push is basically happening and we are properly fine, right? So everything is done. Just validate it from the GitHub if you want. So here you can see that if I load it, and here you'll be able to see 4 commits, right? So the 4th commit will basically be this commit, the web app is ready. You can again see the differences, view the commit details, all the information that is added, everything you'll be able to see. Okay, so you can validate this. Now in my next video, I'm going to basically deploy this entirely into a cloud which is called as Heroku. First of all, we'll just see a basic way, and then we will try to see with the help of Dockers. Along with that, we'll also try to see with GitHub Actions, which is basically a kind of CI/CD pipeline. So we'll try to see a bit of MLOps when we are doing this kind of deployment. So yes, this was it. I'll see you all in the next video. Thank you. So guys, till now, we have actually seen completely end-to-end application with respect to this Boston house pricing dataset. And we also saw this by running it in locally by using this both API along with the entire web application. It was working perfectly fine. Now it is time that we really need to deploy this application into the cloud. And the cloud that we are going to consider for this project is Heroku. Okay. Now Heroku is nothing but it is like a kind of platform as a service. All you have to do is that make sure that entire configuration is right and just try to deploy it automatically. It will actually create, or it will give you an instance in the cloud itself, and it will run the entire code over there. To start with, what we are going to do is that if you are planning to deploy in the in the Heroku platform, we first of all need to create a Procfile. Now you may be confused, like what exactly is Procfile? Procfile is nothing but usually Heroku apps. Whenever you probably deploy any apps in the Heroku, a Procfile specifies some commands that needs to be executed by the app as soon as it starts. Okay, so that is the reason why we specify a Procfile. So that, let's say I'm just going to specify over here Procfile. And the one thing about Visual Studio Code is that it automatically understands the extension. Okay, now why I am putting this Procfile, because it is basically indicating, or it is giving a kind of command to the Heroku instance itself, that on start, on startup, right? So basically when this entire application is started, what commands needs to run. Okay, and the commands that we are going to use over here is something related to G unicorn, that is the green unicorn, and you know why G unicorn is basically used, right? G unicorn is a pure Python HTTP server for WSGI applications. It allows you to run Python applications concurrently by running multiple processes. Okay, so that is the reason why we really need to write G unicorn. We need to use in this Procfile. Okay, so how do I write this specific command over here? So you just have to write web : okay, G unicorn app. Okay, now why I'm specifically writing this all things. Okay, let's go ahead. Now, Unicorn, as I said, that it allows the entire Python application to run in an amazing way because it creates multiple Python processes. So based on the number of requests, whenever the client is putting, or probably let's say thousand of users are hitting this particular website, whatever web application we are creating, it makes sure that it distributes the entire request through multiple instances and many more things, right? That is the importance of Unicorn in short, right? So over here, when we call this Unicorn, app is nothing but we are basically calling this app.py file. And inside this, that our app name is, again, our application name is something called as app. That is the reason why we have written like this, app colon app. Okay. So this is the one of the changes that we have to do. The other changes is that in requirement.txt, since we are using in the Procfile Unicorn, here also we have to make sure that we upload this Unicorn so that the installation will take place uh, as soon as this requirement.txt file will run. Okay. And this much files, like, see, when we are giving this requirement.txt, when we are giving this Procfile, automatically the Heroku instance will understand, okay, understand that, okay, if requirement.txt is there, we have to make sure that we have to install all the libraries over here. Okay. Now, so these are all the things, the final conclusions, the final updates. We have to make sure that we have one proc file, we have one requirement.txt. Now we need to upload all these things into our GitHub, right? And from GitHub, what we are going to do is that we are going to deploy that in our Heroku cloud. Okay. So committing into the GitHub, I can give you this as an assignment. Please make sure that you write some git commands, that is git add dot, and then you try to commit this and push it into the GitHub repository. So this will be an assignment for you. Please do it. Okay. So guys, in the next video, what I'm actually going to do now is that in the next video, we are going to do the deployment. Okay. So I hope everybody is should be able to do this configuration setup with respect to creating the proc file and updating the requirement.txt and finally committing it into the GitHub repository. Okay. So yes, I will see you all in the next video. So finally, guys, all the file has been committed into the GitHub. Now all we need to do is that do this entire deployment in the Heroku. Now there are multiple ways of doing the deployment. I will first of all show you the most easiest way. Then in the upcoming videos, we'll be seeing with the help of Dockers and CI/CD pipelines. But this time, just a very simple deployment. I have created the proc file. I have all the requirement.txt. You can basically see in the requirement.txt, I have Unicorn. Everything is available. Okay. Now, first thing, just go ahead and log in into your Heroku dashboard. So once you log in, let's say that I've logged in over here. In Heroku dashboard, you can actually create 5 different applications for free. So we'll try to create over here. And the most easiest way we'll try to create will not probably use any command line interface to deploy or do anything. Just drag and drop everything, clicks, that things will basically be doing. Now, first of all, I will go and click on new, create new app. Now here, let me just go ahead and write Boston house price 1. Okay. So this will, okay, it is saying that not available. Okay. Not a problem. Boston house pricing 1. So this is basically available. I'm just going to go ahead and create the app. Okay. Now, once you create the app, here the deployment methods that will be shown will be 3. One is Heroku Git, one is GitHub, connect to GitHub, and one is containery registry using Heroku CLI. Right now, I will not be doing this Heroku CLI or container registry CLI. Let's go ahead and do it with the GitHub. Okay. So right now, just go ahead and click on GitHub, and then it will probably tell you to connect it and validate it to your GitHub link. So here you'll be able to validate it. Now go and search for the repo that you want to connect. I have already validated it. So if I probably search, I'm actually getting Boston house pricing. Okay. So now I will just go and click on connect. So once this is connect, that basically means this entire repository is connected with my deployment platform. And remember, Heroku is a platform as a service. Okay. All you have to do is that you have to make sure that you give this entire files from the GitHub. Automatically, it will do the installation. It'll see the requirement.txt and everything. Now, Over here, you can see we can also enable this automatic deploys. If I enable it, that basically means anytime any changes that I make over here, automatically the deployment will happen in this Heroku platform itself. But I'm not going to enable this because I will just do the deployment whenever I will like. Okay. But usually, whenever we create a CI/CD pipelines, we usually make sure that this automatic deploy will be there with respect to various platforms. Now I will go and do the manual deploy. So this entire GitHub branch, that is the main branch, because I just have one branch over here. That is my main branch. This entire branch will be deployed into my Heroku platform or Heroku cloud. So I will go and click on deploy branch. Now here you'll be able to see everything. All the process will basically start. Okay. So here you can see building Heroku 20 stack, installing Python 3.10. Now see, we did not give any Python version in requirement.txt, so it did not get any version, so it has started installing this. Otherwise, if you give Python 3.7, it will install Python 3.7. Then you can see FLASK is there. Always remember, if we have a higher version, the older version may also work. Okay, unless and until it is not a major switch from Python 2 to Python 3. Okay. So here you can see pandas, matplotlib, gunicorn, dependency of gunicorn, everything is updated or downloaded. Scikit-learn is also there, which is the recent version. Everything is downloaded. Okay. Now this is a thing, because in requirement.txt we have to also upload some of the packages, but I think this will also work. Okay, but again, if you have a larger application, you may find some of the dependencies and problems over there. In order to fix the dependencies, we'll focus more on Dockers. Okay, at that point of time, we don't have to worry much on that. Okay, so here it is. I think the deployment has basically happened. Here, what you can do is that you can also check the logs. Okay, so if you probably go and click on logs, here it will be showing if you have any kind of errors that are coming, you'll be able to see over here. Right now, it shows build succeeded. Perfect. Now I'll go down and let's go ahead and see our web application. So now perfect. Oh, wow, this is amazing. And just in one click, I was able to see all this application running fine. And this is where my Boston housing price one.heroku.app.com is basically working. So let's test this. Let's test this. So I'm just testing it. I'm putting some values and let's see whether the prediction is done or not. So we have now predicted. So here you can see that everything is working fine. The prediction is also working fine. Now, if I really want to check the API also, I can go ahead and check it. I will go and open my Postman. Okay, I will change this entire URL. Okay. And here I will write predict_API. Okay, so that API is also there over here. And all these values are given. I'll just go and click on send. So once I send it, you can see I'm also getting the right value. Okay, and I can definitely play with any value that I want. Okay, so here you can see 30.32. Suppose let's say this is 0.8832. So here you can see 30.22. So all things is working. API is also working, and my FLASK app is also working over here. And with respect to anything, the logs will be created over here. Any errors that you're getting, you can see all the print is basically happening. You can validate it from here itself. So perfect. We have done the deployment. It's quite amazing. The first deployment in the Heroku, the first end-to-end project, probably in our course, that we have done the deployment. Now we'll go ahead and learn about Dockers, and we'll see what will be the advantages if we use Dockers and if we try to do the deployment also. Okay. So yes, I will see you all in the next video. Thank you. Hello guys, in this video I'm going to deploy a machine learning application into a cloud server like Heroku with the help of Dockers and GitHub Actions. Okay, now GitHub Actions, whenever I say, I'm basically talking about CI/CD pipeline. That basically means as soon as I commit anything from here, automatically the deployment should happen into the server. And before that, I'll also make sure that I will try to Dockerize this entire application that I've actually created. Now, right now, here you can see this is my machine learning application, a simple machine learning application. And this machine learning application is nothing but Boston house pricing data set we have basically used. So whenever I probably have created a front end, wherever I put inputs and predict it, it is going to give me the price of the house. So first of all, let me quickly run this. And again, guys, I've created many this kind of project videos, so you can definitely watch that. But here I've directly written the code, probably done the exploratory data analysis and all. So if you really also want to refer this, definitely refer it from the GitHub. Okay, but I'm not going to implement this because I've done it many number of times. So first of all, if I just go and write Python app.py, here you'll be able to see how my output will look like. Okay, so it is running. Let's see. So for the first time, I think it'll take some time. Anyhow, I'm just going to run this 127.0.0. Now here you'll be seeing that my application will look something like this. Okay, so my application looks something like this. So here I'm just going to put up some information like this. Okay, let's say I'm putting up all the information like this over here, and if I probably do the prediction, and this is right now in localhost, right? And I'm going to get the prediction something like this. Okay, now what I'm actually going to do is that I'm going to basically deploy this. I'm first of all going to Dockerize this and run it as a Dockerized container. Okay, and what is Dockers and all, I've already created a playlist onto that. Just understand that Dockers saves a lot of time with respect to configuration setups and all, right? Because the entire configuration is basically made within a Docker image, and that can be run as a container anywhere. Let it be your operating system or some cloud server, wherever you want, you can basically do it. Okay, so what I'm actually going to do, again, I'm going to minimize this. Let me just do Control C. Now let me just show you, first of all, this step. We will try to create a Docker file. Now in order to create a Docker file, it's very simple, not that difficult to create a Docker file itself. All you have to do is that within this, just go and click over here, write Docker file, and make sure that you use this same naming convention. Then automatically VS Code will be able to determine whether it is a Docker file or not. Now with respect to the Docker file, whenever we create, the first thing is that understand what exactly is Docker image. Here, with the help of this file, whatever information I am actually writing, it actually creates a Docker image. Okay, and that Docker image can be taken and it can be run within a container, which we specifically say it can be run as a Docker container in any operating. Suppose if I also want to run in my local, we can run this entire Docker image as a Docker container, which will be interacting with the kernel of our operating system. Okay, it is not like a virtual machine, but you can just understand it is a kind of container which can independently run by communicating with the kernel of the operating system. Now in order to create a Docker image, first of all, there are some commands that we'll be using. One is from command. Okay, now what is this from command? I will discuss. The next command is something called as copy command. Copy. Okay, the third command is something called as work directory command. The fourth command is something like run command, and fifth command is nothing but expose command, and then finally my cmd command. Now the from command basically says that whenever, now see why Docker is so super important, guys. Suppose let's say if I don't probably create a Docker with this application, and if I want to give this same application for my friend to run it, right? So what my friend will do, whatever installation I have done, whatever setup I have done, whatever library setup I have actually done, he has to do all those steps manually, right? And because of this, what may happen is that he may face some kind of errors or issues. So that is a major problem over there. Like you have heard this saying, right? When QA is working, right? Suddenly, let's say when developer is working in the developer in a developer machine, suddenly they deploy the code into the QA machine. When the QA is basically testing, they'll say, oh, something is not working. Developer says that, oh, it is working fine in my system. So what is the main issue over here? There may be some kind of configuration, some kind of dependencies, some kind of hardware issue, or some kind of operating systems issues also, right? Because let's say I'm running an application in Windows machine and suddenly I deploy that in a Linux machine, I may get some kind of issues over there also, right? So Docker helps us to prevent that, because here in the Docker image, we will make sure that we have all the base configurations set up then and there, and we'll try to use that same base configuration in every machine we want to deploy it. Okay. So first command is from. Now this command is basically used to select any kind of base image. Okay. Now, as I said that, see, Docker container also requires some base image. Base image means that, okay, we can have a Linux operating system on top of that installed something, right? So suppose if I write from Python 3.7. So what this is going to do is that I'm not going to use Alpine. Okay, Alpine is again another different version, okay, of base image. Now, as soon as I write Python 3.7, when we are building this Docker image, it will go and take out the base image from the Docker hub, wherein it will take probably this Python colon 3.7 basically means it will take a Linux base image, and on top of that it will try to install, probably let's say a Python 3.7 is installed, it is going to take that particular base image and it is going to do the necessary other configuration settings. So in short, what happens as soon as I write from Python 3.7, all it is going to do is that from the Docker hub, because all the images are present over there, it will take that particular base image which has Linux, on top of it Python 3.7, and then it is going to do the next step, that is copy. Copy basically means whatever code I have in this repository, see all these 4 files that I have in the repository, I need to copy within that particular base image, right? All these files within that base image. So for that, what we will do, I'll just say copy from my current location, location to a location which I'm going to name it as app. So that basically means I'm going to create an app folder within that particular base image, which will be copying all my local content to that particular app folder. Okay. And then the next step is that I'll create that as my working directory. So here also I have to give my same location. Okay. This is super important. 3 steps from I've taken my base image, I made sure that I copied all the content, all my code from here to a app folder inside that particular base image, and I'm making that as a working directory. Now the next thing is something called as run. Now see guys, here also whenever we run any machine learning application, there will be some dependencies. In this particular case, requirement.txt, if you're doing a JavaScript project, you probably have to install some of the packages and all. So I need to install all these things before going ahead. So for that, I will be using this run command. Now inside this run command, I'll write pip install -r requirement.txt, right? So this will do all the installation, or the dependencies will get installed over here. Finally, I will go and expose. Now see, inside my Docker image, when that Docker image is run as a container, right? In order to access the application inside the container, we have to expose some port. Then only we'll be able to access that particular entire URL, right? Because from that port only we'll be able to access that application. So we are going to expose a port within that particular Docker container, and that port, I will just write it as a placeholder, which is called as $port. Why? Because this value, when we are deploying into the cloud or server, right? It is going to, the server is going to automatically, or the cloud is automatically going to assign this particular port in that container. Okay. So this is the next command. And finally, I will run my command, which is basically used to run my web application, or in this particular case, my entire application. So for this, I'm going to use gunicorn. Okay. Gunicorn actually helps you to run this entire Python web application inside the Heroku cloud itself. So here I'm going to assign 4 workers. Workers importance is too much, right? Workers, what it does is that it whenever a request is coming into the application, it will divide based on the instances. Okay, it is, let's say 1,000 requests are coming. So if I'm using 4 workers, it is going to take 250 requests with one, 250 another, like that parallelly, different types of, just to make that particular process easy, right? Then I'm going to also bind. Now this IP address will be the local address in the Heroku cloud, and then I'm going to assign with port. And this will basically be my app file along with that app file. So see over here, this app file is basically the file which is where I have to run my application. Inside this will basically be my app name, right? So that is the reason why it is written app:app. App::app basically means we are just going to take this particular file. Inside that we are going to run this. Okay. So app::app will be basically the entire process. Okay. So we are just trying to run the first file over there, and over there app is basically my file name that is present inside this. Okay. So that is what we are going to do. So this is what is the entire configuration over here. What this binding is doing, this is super important, guys. See, understand about this particular binding, very important. This port number, whatever we have exposed in the container, that will be getting binded to the local IP address, whatever local IP address we will be getting in the Heroku cloud, right? So that particular local IP address. So it's just like a local host address 0.0.0. I know it is 127.0.0 in our machine, 0.00.0 we can assign it over there. And this port, whatever port Heroku is assigning in the container, will be able to access it over here. Okay, very much super clear, very much simple. gunicorn is definitely required whenever you try to deploy anything in the Heroku cloud platform. Okay, simple and easy. Okay, now this is done. This is my Docker file. Now the next thing that I'm actually going to do, since I also need to make sure that I have to configure my GitHub Actions. Okay. Now, in order to configure the GitHub Actions, whenever you want to configure GitHub Actions considering CI/CD pipeline, two folders needs to be created. One is .github and the other one is something called as .workflow. Oh, sorry, workflows. Okay, workflows. Now, why I have created this file? Because as soon as I deploy or I push this entire code into the repository, GitHub repository, you know, when they sees this particular thing, GitHub workflow, and inside this I will also create a file which is called as main.yaml file. This will have the entire process. As soon as I commit, what all things we need to do. First thing is that we need to build this Docker file. Build this Docker file basically means the entire image needs to be built, and then we have to push this image in the form of a container to the Heroku platform. Okay, so the entire configuration over here will be set up in this main.yaml. Now guys, this kind of main.yaml, we don't write everything from scratch. They're already available. Some people have already written this. I'm just going to copy and paste it over here, but just understand what is my workflow. This main.yaml will define the entire workflow. Okay, so here I'm just going to say your workflow name. This is deployed to Heroku. For in which branch it is basically on. As soon as from here any push command goes onto the main branch, then what will happen is that this entire build process will start. Main thing we are trying to do is build, push and release a Docker container to Heroku. Okay, so it will run on the Ubuntu latest. It will take a Ubuntu operating system and do this entire process over there. But here you will be seeing that you require three main information. One is Heroku email, Heroku API name, API key and Heroku app name. Now these three information are super important. Now the thing is that where do I get this specific information? Obviously from the Heroku itself, right? So Heroku, here you can see that I have logged in. Let's say I want to deploy inside this Boston house pricing one. Okay. Now if I want to get this information, these are my secret keys that is available that needs to be provided in the GitHub Actions. So if I probably go over here, just a second. If I go over here, and probably let's say I'm going to my Boston house pricing. Now if I go to settings, okay, in the settings there will be something called as secrets, because I have to make this as a CI/CD pipeline as soon as I push my code to this GitHub repository. So I have to add some secret keys. Now click on secrets, click on new repository secret, and here I will basically write my new repository secret. The first repository secret is basically, let's say I want to add Heroku API key. Okay, so I will go over here, copy and paste Heroku API key. Now where do I get my Heroku API key? Just go into this dashboard of Heroku, go and click on account settings, and here if you go down, here you will be seeing API key. Just reveal this, copy this entire thing and paste it over here. Okay, so I'm just going to paste it over here. So this will indicate that which Heroku app is my information. Like I want to deploy, this will indicate which account I'm actually using in Heroku. Okay, so as soon as I click this, a secret key is getting added, but we need to still add two more secret keys. So I'm just going to click on new secret key over here, and now my second secret key will be what? It will be Heroku email. The Heroku email will be the same email ID that I'm using for my Heroku web app, Heroku dashboard. So it will be krishnaik06@gmail.com. This is just to give this configuration so that my deployment will happen successfully. Okay, as soon as I do any push to the GitHub repository. So this is my Heroku email. Now similarly coming to the third one, it is Heroku app name. Now Heroku app name is super important because in which app I need to deploy my code, right? So here I'll be writing Heroku app name, and again I will go back to my account and let's go back. Let's say I want to deploy it in this Boston housing pricing, right? So I'm going to copy this. I'm going to paste it. Okay, I'm going to paste it over here. Now here I will just go and add this secret. So this all information is perfect. We have added it. Now what will happen? See, we have set up the GitHub Actions. That basically means as soon as now I deploy anything over here, right? Right now you can see there is no GitHub workflows folder. Only it is present over here, right? Now as soon as this folder has been seen and whatever file is basically written over here, all these things will get deployed. All these things, all this process will automatically happen. In short, the build, push and release of a Docker container to Heroku will happen automatically from the GitHub repository itself. Okay, and this is super important, this build, push and release, because there will be many people who will be working in a team, right? and many people may commit multiple things, right? And every time if a build, push and release actually happens, then every time we'll be able to understand what error is actually happening. Someone may do some kind of errors over there. So every time this build will be a very important step to go with, right? This is what we basically follow in real world industries, where we are specifically moving our content from development to staging to pre-prod to production, So with this kind of containers, we'll try to create and we'll try to push it. Okay. So this is done. Now let's go ahead and open my terminal. Now, as usual, I'll go to my environment and now I will add everything that I have actually done. So git add, if I probably see git status, you'll be seeing this many number of files has been created. Okay. And I'm just going to push this. Okay. Let's see whether I have missed anything as such. No, nothing. No. Okay. Everything is here. Perfectly fine. Okay. Now I'm going to just push everything. Oh, sorry. Before that, I need to commit the snapshot. So I'll write -m. I'll say Dockers and GitHub Action changes commit. Okay. Because I have initiated this. So this is done. Now all I have to do is git push from origin to, I don't have to write to, push from origin to main. So you can see that everything has got done. Now as soon as I open GitHub, right, now see what something amazing will happen. Okay. If I reload this, some orange color will come over here. See. Okay. Now let's go and see the commit. So here I will go and click it. Now you see this entire details. Automatically this entire deployment is happening. Okay, something went wrong. Input required and not supplied Heroku app name. So something wrong is there. So let's go and see what is the thing that has gone wrong. Heroku app name, I had actually provided it, but I don't know what happened. Okay. Okay, see, app underscore name should be there, right? So let's do it again. I'll add a new repository secret. Okay. New repository secret. I will go again back to my optional over here. Let's see. This was the entire app name, right? I wrote only app underscore name. Okay. So now here app name is nothing but house pricing dot this. Okay. So because of that it failed. See this? Because of that it failed, right? We will fix it. No need to worry. We will fix it. Okay. So now I will just copy this and I will add it my secret. Add secret. Perfect. Now let's build or rerun this. Rerun this job. Rerun all the jobs. Okay. A new attempt of this workflow including all the jobs. Yes. Rerun these jobs. Okay. Either you can rerun it or either you can do this. Okay. So now you can see build has actually started. Okay. So the build has started, the job is started. Here, first of all, it has taken the Ubuntu, whatever configuration we have given. Now see every step, even building of the Docker will also automatically happen, right? Every steps will probably happen over here. Pull, commit this, download, verifying checksum. See this copy process is again happening. Working directory changes is automatically happening. This is quite amazing, guys. This pip install is basically happening. And all the steps are happening. You can see over here, right? All the requirements are getting installed. See this build process. You did not do much anything, right? Automatically these things are happening. That is the power of CI/CD pipeline. That is the reason why DevOps and MLOps jobs are heavily required in every companies. This process with respect to every project you have to do, right? So this is going to take some time. Anyhow, I will just wait till all this installation will take place and then we will again start the installation. Okay, sorry, we'll automatically see at the end of the day when this entire thing will happen, it will get pushed to this particular Boston housing price app itself, and then once you open the app there will be able to see the output. Okay, so let's see. Okay, still happening. Layers already exist. Pushed. That is going to probably take some time because there are many files, many installation will take place. This entire process will get run. If you get any errors, you can again rerun it. Try to always get errors. If you get errors, that basically means you will be, and if you are able to solve it, trust me, you are able to learn in an amazing way. Okay. So pushed. Now I'm just going to pause it, and once it is pushed, we will try to see the application. Okay. So I'll just come back in some time. Till then, I'm going to pause. Oh, see. Okay. Releasing container. Okay. Releasing container. All the steps you'll be able to see. And please note down all these steps, guys. These steps are super important. Whatever things we have written in Docker, everything is happening because this is now getting created as a container. Now finally you can see my job is completed. Now I'll go over here, open the app. Ta-da! Ta-da-da-da-da-da. Let's see. Still nothing is working. Okay. You can also check logs if you are probably finding any issues in Boston house pricing. Okay. And ta-da! It's here. And let's now go and execute it. Okay. Let's go and execute it. Here you go. Here you go. Here you go. Here you go. And now this entire thing is running in a Docker container. If you don't believe me, I'll show you that also. I'll show you that proof. Once I predict it, this is my output. It's working absolutely fine. If I probably go over here into personal, here you'll be seeing now it is running as a container. See, before if you just deploy a Python application, it will look like this. But if you are deploying it as a container, you will be able to see like this. Okay. So I hope you like this particular video of deploying your data science application into Heroku Cloud with the help of Dockers and GitHub Actions.